And the session will be co-chaired by Dr. S. Velamurugan, Chief Scientist, Central Road Research Institute. May I please request you, sir, to kindly join us on the dais. Everybody please give him a round of applause as well. And now may I kindly request Sri Shubhranshu Sekhar Swain, Superintendent Engineer, Works Department, Odisha, to please come to the dais and present a bouquet to Sri Uttam Parsekar, our chair of the session. We all welcome you, sir. And now may I kindly request Sri Shubhranshu Sekhar Swain, sir, to kindly welcome our co-chair of the session, Dr. S. Velamurugan. Thank you so much, sir. And now I invite all the presenters of the session to please come on the dais one by one. Dr. Vijay Balakrishnan, Assistant Professor, IIT Tirupati. Professor M. Amaranath Reddy, IIT Kharagpur. Professor Akshay Gundla, Assistant Professor, BITS Pilani, Hyderabad Campus. Dr. Jaya R. Shinganmakki, Professor, BMS College of Engineering, and along with her, Sri Manju Nath. And last but not the least, Sri Prabjot Singh Gandhi from IIT Jammu. May I kindly request all our presenters to kindly join us on the dais. Once again, I'm just repeating the name of the presenters. If you are not here on the dais, please feel free to join us here. Dr. Bijali Balakrishnan, Assistant Professor, IIT Tirupati. Professor M. Amaranath Reddy, IIT Kharagpur. Professor Akshay Gundla, Assistant Professor, BITS Pilani, Hyderabad Campus. Dr. Jaya R. Singanmakki, Professor, BMS College of Engineering, and Sri Manju Nath. Sri Prabjot Singh Gandhi from IIT Jammu. We have all the presenters? All right. So now, may I request Sri Uttam Parsekar to start the session with his opening remarks. Please, sir.
Good afternoon. We are a bit late, so nevertheless, we'll catch up. I have the privilege of chairing this technical session for accommodations. I myself is an academician, still pursuing my PhD. Dr. Raju, he has been my mentor during my MTech. So it's nice to be back in the groove of academics. So I wish all the best for all the presenter. And only one suggestion, let's academics and the practice on the field. Let's go hand to hand together. All the best to all.
Thank you so much, sir. May I kindly request everybody kindly put your phone in a silent mode. If your calls or messages are not that important, kindly don't take it. Let's start the session from here.
Yeah. The first presentation, performance-based design and structural evaluation of UHPFRC girders by Dr. Vijay Balakrishnan, Assistant Professor of IT Tirupati. And time allotted will be round about 8 minutes. So try to put it in within the time frames because we are already late. We'll try to catch up as soon possible. Presenter, Dr. Bijli Balkrishna.
8 minutes, and then we'll give a start to
2
you.
minutes are grace period.
2 minutes, 8 is.
Yeah, I'll do that. Can it go to full screen mode? Yeah. And can you go to full screen mode is possible in this system?
You can use this pointer.
I'll do that.
You can scroll to this one.
Yeah, but it's not visible.
Just a minute.
Thank you. Thank you. Can you hear me? Yeah. Okay, so I have too many instruments in my hand. I'm not sure how to utilize all of them, but let's try to give you a brief of what I would like to say in 8 minutes. So, structural evaluation and performance-based design of UHP FRC girder. That's the title of the topic. What we are trying to actually bring it to the audience here is UHP FRC is not a new material. People have already started knowing about it for at least 10 years. Now it has taken up. And in India, it is slowly growing. We don't have much companies who is doing it. But then it has its potential. So my agenda of this presentation is to give you the potential of the material and at the same time highlight what is the probable mistake an engineer may make it when we actually use this material. So, okay, the first instrument in use, I hope you can see, this is the general outline of the section. I'll start with the introduction of UHP FRC. So, everybody knows the material composition. I'm not very, highlighting it. You have a lot of cement in it, silica sand, silica fumes, fillers. It's highly dense material. That is the major output of this particular compositions what we use. It provides significant tensile resistance and crack control compared to a normal concrete, what you find out, or even a fiber reinforced concrete. This has a better performance. Durability point of view, it performs very well, and it is found to be sustainable in the use of, especially in the case of bridges. Now, people do use this extensively. In India, it's commonly nowadays used for the bridges. There are few places it has been tried by the companies in the high-rise buildings when you have to have a long columns or a long span girders or the beams for an auditorium. Those are the applications have done. But this material has its own dangerous part along with it. So when we use normal concrete, we always say it is highly uncertain, a highly non-homogeneous material. When you add fiber to that kind of composition, you make it much more, a non-predictable material. Now, you have to have a good quality control to maintain the material composition and get the properties what you're looking at. So once you get that, which one I should use? If you today look at, you will have lot of UHPC mixes, either proprietary or non-proprietary available in the world. And it costs a lot. In India, 1 m³ of UHPC mix costs minimum 1 lakh rupees. It's not a small amount. People who get a normal concrete starting from M30 to M40 to M60 costs 4,000 to 8,000 to 10,000, and the ranges where what kind of applicability. It is an SCC concrete. There are slight changes in the prices. So it's almost 10 times. Can I blindly use the material just like that? Yes, people are doing that. But the basic disadvantage with it, you are not economical. You are making or you're wasting a lot of material while you do that. So you have to do optimization in your material mix to obtain a critical parameters what you're really looking at. Those parameters should be defined, and based on those parameters, you get try to produce a performance which you're looking at. So there are different intentions of a structural designer when we do a girder. You want to have this particular failure mechanism. You want to have this amount of ductility, depend on the structural performance. So you have to target that particular structural performance, where you have to ensure that the constituent you use in the material side, which normally a structural engineer won't look at, because we always worry about a compressive strength comes out to be what is the maximum compressive strength of a concrete. That's a straightforward structural engineer question. That's not sufficient. You need to know the material composition. You need to know the property of that material in terms of both in compression and tension for a material like UHPC. And that is not the peak strength, which is always the question. We also should know the complete stress strain graph, which is in which this property possesses both in compression and tension. Now, how it is playing a role, that is something I'll try to give you. If I use one particular type of material, what you see here in the image is a load versus displacement graph, where I have used both the beams are UHPC concrete, both use UHPC in general with a strength of more than 120 to 150. We supposed to, or we have provided same extent of reinforcement. Imagine that. I haven't altered anything else. But the constituents of UHPC I used on the one and the next is different. So how it alter? Until the peak, it will not change much because there is no much crack has happened. Once the system starts cracking, it will have a nonlinear behavior. There is somewhere a rebar yielding will happen. You may get a rebar fracture in the case of UHPC because being high compressive strength and a tensile strength of the material. Or after rebar yielding, it can further go up and get a UHP FRC crushing. Now, what all things actually dictate the failure among these two is relevant because one will provide a ductile failure, one is actually a sudden failure. So my intention to understand the parameters which actually
Dr.
give
Balakrishnan,
me...
3 minutes, 3 minutes, 3 minutes, 3.
I know, sir, I know. The material which will give me a ductile failure. In that sense, I am looking at the parameters which can probably inform that, influence that structural design. As usual, every structural engineer knows the longitudinal steel, pre-stressing, and the sectional property will influence. But in addition to this, this material, where the compressive constitutive relationship, which means the strain graph of UHP FRC, and the tensile constitutive relationship, both will influence. And that comes from the material constituents. It is not the compressive strength or M30 or M40 is relevant or M125 is relevant. It is the relevance comes from the complete constituent which give you a typical stress strain graph. In this study, we have, I'm not going again deeper, but existing codes normally go with a prescriptive method where you can understand that a set of numbers is given to you. You will just follow them blindly and design it. You can do same for UHP FRC as well. The only difference is your section will be highly uneconomical. You will unnecessarily waste a lot of material, which eventually kill like your cost part, right? So a performance-based design can give you a cost-effective, in the same time, highly structural performance which you really want to have. So a framework, I'm just avoiding the technical, too technical stuff here because I have another 5 minutes probably. So this is the flowchart of a performance-based design. From there, what we get is something like this. This graph, what you see here, is a moment curvature graph, where I am dictating what kind of failure or the sequence of failure I should have. I want to have a cracking. It's a pre-stress section I have analyzed. So that because of that, I have a preloading stage here. Then I should have a cracking point. After that, a post-cracking stage will come. There I'll be starting with rebar yielding because normally that percentage will be slightly lesser. So it yield first. Then I'll have a tendon yielding. Then I'll reach something called crack localization where one of the crack will get widened a bit faster. Then at the end, UHPC FRC crushing. This is an ideal performance we will be looking for. Reason being, it provides a lot of ductility to the system. Now, to achieve this, you may not need everything a UHP FRC company offers you. You may need half of them, 60% of them, in terms of when I say the properties what we look at. So actually to establish this, our framework, we first validated it. So this is the validation of the framework. So after this, we did a very detailed parametric study. There we have tensile constitutive relationships, and we studied the compressive strength importance. We studied the longitudinal reinforcement and pre-stressing tendon. How much more time? 1 minute? Okay. Can I take 2 minutes? So what we understand from this study is one of the very key parameter in a tensile property is the peak strain. Okay? So maximum peak strain, if it can achieve, that maximum I'll get the possible enhancement in the strength. So in general, concrete tensile strength will not influence much, but in case of UHP FRC, it do have an influence. That's one thing. Also, we expect to have this elastic strain, what you see here in this point, if that is a lower number, that means a high Young's modulus if you have, you will have a distributed crack. Always distributed cracks are preferable in sense because you will get enough warning. So that really helps you to identify your member is going to have a potential failure. So that is one thing very important. And the peak strength, normally what the marketing agencies of any company which produce this material says, my concrete has 12 MPa, 15 MPa flexural strength. That really sometimes is not necessary. You don't need to have it because if you want to have it, you have to provide so much of fiber in it. But in this case, with a minimum fiber, you will be able to achieve the strength what you're looking at. So as with the limited time, I'm moving ahead to the conclusion. But to understand one very important thing is, we have tried the durability characteristics also, understood that 100 to 1,000 times the parameters are actually better in UHPC compared to a normal concrete. So it is a solution for a sustainable construction, sure, but you cannot just blindly adopt it. You have to have a proper training in the structural design point of view and the execution point of view. So here we were trying to highlight the structural performance point of view, what is the importance of material constitution, and you don't need to unnecessarily go to a strength, either a tensile strength or a compressive strength, too high. You can still make your member economical and an optimized structural design with a compressive strength of more than 120 to 150 MPa and a tensile strength 6 to 9 megapascal. So we have a research group, works in the bridge research group, the group call, and set of team members like PhD scholars and postdoc members are working along with us in this. This is just a gathering of our team member. We are developing a laboratory at IIT Tirupati now. This is one part of the laboratory where we will be able to do a girder study by a full size girder, but will not be more than 22 meter span, maximum 22 meter span. We will be able to test. The lab is under construction right now. Probably in 6 months of time, we will be able to commission it. This is an overall view of the lab. So basically, the lab is trying to have input to the country where probably people have not looked at much. So Laboratory for Innovative Bridge Engineering is the lab name. And we will be looking at conceptualization to repair, maintenance, rehabilitation, all the aspects of a bridge engineering area. This is a sectional view, and this is our beautiful campus. Thank you very much.
Yeah, thank you, Dr. Balakrishnan, for making a very crisp presentation. Anyway, we'll take up the questions at the end. So it's a very good laboratory study you have done, and I hope it will be brought to practice sooner, which gives you the how much that ductile shear behavior is fully established from your laboratory study. Thank you. So we'll go to the next presentation. Development of damage prediction based mechanistic empirical payment design guidelines for India by Professor M. Amarnath Reddy from IIT Kharagpur. So, Professor Reddy, 8 minutes. Thank you. Thank you.
Good afternoon, one and all, chairman, co-chairman, other presenters, and fellow delegates who gathered here for the 84th IRC annual session. So this talk, brief talk, is about the development of mechanistic empirical payment design based on incremental damage approach. It's a multi-institutional research project sponsored by MORTH, where IIT Kharagpur is the leading coordinating institute. IIT Roorkee, Kanpur and BITS Hyderabad is the other partnering institutes. We are taking up this study. If you see the timeline, most of you know that IRC 37, which is the design of flexible payments. So the journey started from 1970, where empirical payment design. Later on, we got a tentative design for strengthening of flexible payments. Later on, IIT Kharagpur put data from R6 project, developed IRC 81, that is called Benkelman beam deflection study. Then there was a revision. First time, the IRC 37 design guideline took a step towards mechanistic empirical design. Earlier it was a empirical design. So it was proposed in 2001. And of course, it was again augmented with more information with performance equations, etc. in 2012. And today we have fourth revision, which is IRC 37, 2018. Okay. And now, because this is based on not on a unlike a rigid payment, it is just based on a vehicle damage factor, not on cumulative damage factor. So a project has been taken up to study what are the issues with IRC 37, because these are some of the failures that we normally observe. Now, you see, any payment design that we take up should address what are the failures that are likely to occur. But IRC 37 2018 only takes care of few kind of things. Like normal failure modes in a bituminous payments are bottom-up crack, top-down crack, transverse low temperature cracking, joint cracks, reflection cracks, etc. These are cracks. Rutting is also there. Rutting not in one layer, but all the layers. Roughness is also seen because roughness values are increasing. And skid resistance is also an issue. And other associated problems also there, raveling, etc. are there. The current guidelines only talks about only bottom-up cracking, but most of the payments, what we have observed, I think Professor Sridhar is also here. So in his PhD also he has observed many payments when you take a core, it's a top-down cracking. There are bottom-up as well as top-down cracking. So this need to be addressed. And only top-down, bottom-up cracking is addressed in earlier guideline. And subgrade rutting and fatigue of CTB layer, which was also introduced in 2018. So what is not there is, the top-down cracking is not there, low temperature, and rutting in various layers. So rutting is a combined effect of all the layers. It's not only on subgrade, but roughness is also not addressed. Now that means we need to include the performance criteria for top-down cracking and rutting in subgrade, granular layers, bituminous layers, low temperature cracking if possible, roughness. So all these things need to be addressed. So therefore, and currently, as I said, that we only have that bottom-up cracking, and the fatigue life and rutting is only criteria, but we don't have these criteria. So therefore, improvement is required because the current guideline only takes care of
only elastic modulus and material properties, also limited material properties are to be taken. But we need to include many more. It is not just elastic modulus and some volumetrics. More need to be taken. For example, if you see the popular payment design called MEPDG in USA, so they define the permanent deformation as this was the
Oh, so
equation.
ready 3 minutes, another 3 minutes.
So the permanent deformation has got this kind of a model. So it's a combination of the permanent deformation is the summation of all the permanent deformations that are likely to occur in all the layers. So these need to be integrated. So this is the equation that they have considered where the permanent strain to resilient strain, this is a ratio. They also use the shift factors. So therefore, there is a need to develop the revised performance models because as I said that only bottom-up cracking is considered, top-down cracking is not considered. And also road roughness, which is also one of the most the parameters that need to be integrated in the payment design. And a new elastic layer theory because IIT PAVE, you know, that software developed from IIT Kharagpur only has some limitations because that time the trucks, tandem and tridem were not considered, only dual wheels are considered. So we need to even see the IIT PAVE software that is available. And a lot of laboratory database we need to create. So therefore, all the 4 institutions, we have joined it together. Each institute will take care of each one of them. For example, the development of database of elastic modulus of all the layers, IIT Kanpur and Kharagpur does it. And development of the, again, emulsions and bituminous stabilized materials, IIT Kharagpur does it. Resilient modulus of the granular layers, IIT Roorkee does it, like that. So we will develop a database of elastic modulus values for different materials, different mixes. Similarly, performance models also will be developed. So I'm not going to details of it. You can see that several performance models also will be integrated. So then we need to estimate the payment temperatures because we don't have much data about how the payment temperature, we have some equations. We need to verify actual payment temperature so that correct binder can be selected. So all these things are to be kept in view, which are not considered in the existing guidelines. So therefore, we started collecting a lot of data from the Allowed India, almost 100 test sections in the country. And finally, we suggest a methodology which looks like MEPDs of US, where temperature, moisture, top down, bottom up, all these things are considered. So this is the overall model which we are going to say. It's a big project. So as I said that, IIT Kharagpur, what we are doing is this is IIT PAVE software. So now we are improving it, okay, to become more versatile, to take care of all the loads. This is what we have started working on it. We also started collecting the temperature data. So we are also planning to install some weather stations at some locations and try to collect the continuous data, cloud-based kind of things.
Can you come?
1 minute. It's over. So this kind of data we are collecting. So each institute is taking 25 test sections, okay, near to their places, like BITS Hyderabad is looking after Telangana and Andhra Pradesh. We in northeastern states like Kanpur and Roorkee is also taking care of. So this is what data we have collected. And these are some of the models we are developing, okay. So even Roorkee also started working on, as I said, on granular materials, and Kanpur on fatigue characteristics and CTB modulus values and endurance limits. BITS Hyderabad is developing a deterioration model for top-down cracking, etc., etc. So I suppose you know that Kharagpur has contributed immensely in the payment design. So maybe together with all other institutions and data collected elsewhere, so you will have IRC 37, a new version, maybe 2028 or 29, with the MEPDG kind of things. So finally, to conclude, a multi-institutional MORTH research project coordinated by IIT Kharagpur involving Roorkee, IIT Roorkee, Kanpur and BITS Hyderabad, that is on development of mechanistic empirical payment design based on incremental damage approach, similar to your rigid payment design. So there will be improvement version of existing guidelines, similar to MEPDG will come out. So a lot of performance data we are collecting, A lot of laboratory investigation also happening. It is not just laboratory, a lot of field data is going on. So models are also being prepared for controlling the top-down cracking, etc. There will be improved version of IIT Pave software, and the expected outcome is definitely a improved payment design guidelines to take care of the issues which I told you. So we would like to thank Ministry for sponsoring a multinational, multi-institutional project which they have started long back, but now it has started. Also, we would like to thank all NHA, both officers at Delhi and all different PAUs, ROs who are helping us in not only sharing the data, but also helping in the data collection. Thank you very much.
Yeah, thank you, Professor Reddy. I will give a big round of applause to you. And yeah, in fact, we understand this such an important study you are doing. Like it's not, we are not giving justice to the kind of work done presented by both the presenters. Especially this one, I understand it's done on the lines of R6 study, or otherwise recently at CRRI we tried to do a Indian Highway Capacity Manual. So such kind of study, if it is present to a larger gathering, maybe IRC will take care of giving you a separate forum for making a presentation, so that we can take more inputs from the audience. Thank you. So we give one more big round of applause to you. Thank you very much. Thank you. So we'll go for the next presenter. Basically, enhancing safety of Indian highways using continuous friction measurement by Sridhar Raju and his colleague Akshay Gundla. Both are from BITS Pilani Hyderabad campus. So I request Gundla to make it in 8 minutes. Thank you. Thank you.
Sir, you continue with the next presenter. They did not load my presentation.
Okay, thank you. So, in the meanwhile, we'll take up the fourth presentation listed. That is by Dr. Jaya of, she is a professor from BMS College of Engineering, Bengaluru. Her topic is experimental study on mechanical and durability properties of geopolymer concrete with the binary blend of GGBS and fly ash. Very interesting. Thank you. 8 minutes, madam.
Yes. Good afternoon. I am Dr. Jaya Shinganmakki, Professor PG Studies, BMS College of Engineering, with my research scholar and faculty, Mr. Manjunath V, who will be presenting today's experimental study on mechanical and durability properties of geopolymer concrete with binary blend of GGBS and fly ash. The table of contents, the introduction, methodology, the literature review, materials and methodology, experimental results, inferences and recommendations. Just to give you an introduction about the material geopolymer concrete, in the scenario that there's a large-scale production of cement, and which is posing a huge environmental problem on one hand, and unrestricted depletion of natural resources on the other hand, there is a huge requirement for some alternatives in this field. It is said that each ton of Portland cement concrete produces loads about 1 ton of carbon dioxide to the environment. So concrete is a dominant construction material today with an annual worldwide production of about 4.5 billion metric tons. Fortunately, within this scenario, a new player has emerged, and that is geopolymer concrete. So the present research is focused on the pozzolanic materials by replacing OPC with industrial waste like fly ash and ground granulated blast furnace slag, GGBS. So the binary blend of geopolymer concrete is a very promising method where two types of binders are combined to enhance concrete performance. So typically, fly ash and ground granulated blast furnace slag, that is GGBS, are combined to make use of their individual advantages. Fly ash actually contributes to the enhancement of strength over time and improved workability, while GGBS helps in the achieving the higher early strength. So this was formulated by the French professor David Owitz in 1978, who proposed that an alkaline liquid could be used to react with silicon and aluminum in a source material like maybe a geological origin material or an industrial waste material to produce binders. So because the chemical reaction which is taking place is polymerization, the word was coined as geopolymer. The silicon and the aluminum oxides in the low calcium fly ash reacts with the alkaline liquid to form a geopolymer paste that binds the loose coarse aggregates, fine aggregates, and the other unreacted materials together to form the geopolymer concrete. So as the case of Portland cement here also, 75 to 80% is the aggregates, that is the coarse and fine aggregates in geopolymer concrete as well. So geopolymer concrete relies on alkaline activators as sodium hydroxide and sodium silicate to initiate the polymerization. So the key properties, if you list out of the GPC, that it is an innovative construction material and it demonstrates significant advantage in terms of strength, durability, quick hardening, early strength, excellent performance. That's how the literature has been studied and evaluated. Coming to the applications, the real-time applications are also on practical infrastructure initiatives are taken up in Australia, China, and parts of Europe. And the application in slope protection, retaining walls have also begun. The application in engineering practice is gradually expanding in the field of GPC. So coming to the advantages, as I already said, it's got excellent durability, rapid strength, reduced shrinkage, thermal resistance, which can be applied to the pavement engineering aspect as well. There are a few innate disadvantages. Noticeable brittleness problem is there, but the use of certain nanomaterials or fibers can actually promote durability and avoid these kind of brittle fractures. So there is the need of research in these areas. Having said this, it must be mentioned here that the users, the academia, the researchers, and regulatory agencies should endorse the commercial potential of GPC in the background of carbon reduction and hold a positive attitude towards the future applications. The objectives of the present study being to design and develop geopolymer concrete mixes with GGBS and fly ash in varying proportions, investigate the fresh hardened properties, compressive and flexural strength, and durability of GPC to understand the behavior, and to justify the use of geopolymer concrete technology from a sustainable perspective, highlighting its environmental benefits as well. So there, a literature review was carried out, a comprehensive literature review, and there are many studies which have highlighted the use of and advantages of geopolymer concrete.
Another 3 minutes, can you conclude?
Okay, so just to summarize that the literature review has formalized the problem formation for this particular project. The research gaps have been identified and the problem formulation was done. And just a brief about the materials, fine aggregates, locally available M-sand was used as per the guidelines. Coarse aggregates was obtained from north part of Bangalore. GGBS was obtained as per specifications from the JSW plant. Fly ash was obtained as low calcium fly ash from Raichur plant. The alkali activator solutions, which is NaOH and NaSite, was sodium silicate. The composition was fixed and tried for this particular experiment. The activator ratio was maintained as 1.5 by mass as per literature. I request Manjunath to take over the methodology and the results obtained.
Thank you, ma'am. So, coming up to the methodology, we have listed down like this. First, we are going to calculate the material characterization of the materials. Later, we are going to take the aggregates and test it for their material characterization. Later, we have done the mix design using the alkali activators. So first, we will find the dosage of the activators, that is an alkaline solution. Then we will keep it for 24 hours. Then we'll do the mix proportioning with the ratios of different materials which is being used, that is coarse aggregate, fine aggregate, GGBS, fly ash, and activators. Later, we are going to prepare the samples, that is for the cubes and the beams which is being casted. Later, we are going to check the fresh properties, that is the slump count test. Later, we are going to do the hardened properties for about 7 days and 28 days and check the compression and flexural strength. The durability is being checked with the water penetration test. And the experimental results are, so this was the zone 2 of fine aggregate which was obtained. And these are the properties of fine aggregate and coarse aggregate which was obtained, and it was according to the code of IS 383 2016. Later, the mix design was being done using 1745 to 2020.
Another 1 minute, 1 minute.
Yeah, sir, I'll finish it up. Check. Yeah. So the preparation of the alkaline solution was done in the first phase of the mix design, and the second phase was of the preparation of the GPC. Though in the first stage, what we do is we take the pellets of NaOH and mix it with the distillation according to the morality which is there, and Na2SiO3 is taken, and the mixture is called as an alkaline solution, which has been done. Later in the preparation of the GPC, we batch the materials in the dry mix, then add the alkaline solution which has been done before 24 hours, then we compact it and finish it and cure it in the ambient conditions. So these are the steps of the mix design, which I'm not going to go in depth. These are the materials quantities which has been obtained for the GPC mix. So this is for the blend of 50% of GGPS and fly ash. If you have 100% of the mix, which we have done other trials, that will be 430 and 430. So the specimen preparation was done in this format, and the slump count test results were as this. The compressive strength test was done, and we can see that 100% GGPS gave us the good results. That is around M30 grade of normal conventional concrete for 28 days, and GGPS 50% and fly ash 50% gave us the strength of about M20 grade of conventional concrete mix design. You can observe that the fly ash also gave us very less results compared to other two mixes, because the low calcium content in the fly ash was difficult to handle, and the ambient conditions of curing was not sufficient for these type of mix. The flexural strength was satisfactory when it comes to 100% GGBS. This was a water penetration test which was done to find out the durability. This is one of the indirect method to find out the durability of the concrete. And here we got the good results, as the maximum penetration value was up to 25, and we got all that below the levels. So coming to the inferences and conclusions, here the strength development when we add 100% of GGPS was good enough, and also we can recommend the 50% mix of blend of fly ash and GGPS also, to give a performance in the as level to the conventional concrete. And when it comes to curing conditions, the GGPS fly ash blended GPC showed satisfactory strength development under ambient curing conditions. This demonstrates the effectiveness of GGPS in promoting room temperature geopolymerization. And when it comes to economy, all the fly ash based GGPS recorded lower strength values. Its material cost is relatively low due to abundant availability of fly ash as an industrial byproduct, hence it remains suitable for non-structural and low load applications. So when it comes to lastly the durability, water penetration results indicated that GPC durability decreases with increased water penetration among all mixes. 100% GGPS based GPC shows the lowest penetration, confirming its dense microstructure and superior in resistance to water ingress. So the recommendations will be given in the crisp form, that is the merits, as ma'am already discussed, that the mixed combination of 100% GGPS and 50-50 GGPS seems to give promising results, and also it is sustainable material. We are reducing the carbon footprint as well, and also we are using the waste materials like fly ash and GGPS as the materials for the base. So that also gives us a merit of using this GPC rather than using a conventional concrete. So the limitations are, however, these alkaline solutions, and also handling these activators are also a challenging part when it comes to sites, because these are the solutions which comes in a chemical base, and this will be difficult to handle when it comes to large scale production of concrete. And also scope for the future work, we have to try with the different blends again, and also different chemicals which can be used as an activator solution. And here other materials like basalt can be used as a base material.
Can you conclude? Yeah, it's
Yes,
fine.
that is it. That is it.
Thank you. Thank
So
you,
these are
Dr.
the references. Thank you. I would like to thank IRC for providing this opportunity, and also the parent organizations, as well as Rasta for providing this lab setup for this test. Thank you.
Yeah, thank you both Jaya and your student. Thank you very much. And so first of all, we had a good presentation. Now we'll have the last presentation by Akshay on the topic of experimental study on mechanical and durability properties of enhancing safety of Indian highways using continuous friction measurement by Akshay and Sridhar, and Akshay will make the presentation. Akshay, do it in 8 minutes. We'll have good time for deliberations from the delegates. Thank you.
Okay. A very good afternoon, everyone. I'm Professor Akshay Gundla from BITS Pilani, Hyderabad campus. I'm here joined by my colleague, Professor Sridhar Raju, and we'll be talking today about continuous friction measurement and the benefit it has for our Indian highways. Why do we need friction measurement? Well, the recent moth report that was shared earlier this year for the 2023 data, it points out that we had about 4,80,000 accidents in the year 2023, which resulted in about 1,70,000 odd fatalities. Now, when you look at those fatalities by road features, you will realize that almost 70% of them occurred on straight roads, followed by around 8% of them on curved paths. Now, when we look at the weather conditions that impacted these fatalities and accidents, you will realize that most of them occurred again when they were bright and sunny, and only a small portion of that, 8% of that, were occurred during rainy season. But this is the rainy season that impacts mostly the friction characteristics of the road pavement. So let's look at a brief overview of the current status of friction testing in the country. We can broadly classify them into two types. One is using advanced measurement systems like, and then the other one is slider devices, right? So in the advanced measurement system, again, we have two sets. One is longitudinal friction measurement, the other one is lateral friction measurement. Under longitudinal friction measurement, we have our lock wheel testers and then fixed and variable slip devices. And the lateral friction measurement, we have our side friction testers. And the most popular ones, however, are the slider devices, which constitute our well-known British pendulum test, and also dynamic friction testers, which look something like this. Okay, so the main feature of these devices is basically the slider, rubber slider that is attached at the bottom, which can be a shaft or it can be a rotating disc. Now, a few more details. When you look at lock wheel friction tester, it's an intermittent test, so you don't test it continuously, and you test it at 100% slip. That is, the wheel is completely locked when we test it, right? But in fixed and variable slip test, it is a continuous testing, and you don't have to test it at 100% lock condition. And side force friction tester also, they are continuous, but they measure the lateral friction. However, the slider devices, both British pendulum as well as DFT, it is what we call it as single spot or single point measurements. Now, why do we need continuous friction? One, road friction is not the same. It varies along the longitudinal section and also on the lateral section, especially when there is wander effect from the highways, from the road, on the road. Now, as I already told, there are texture variations because of this wander. There will be surface contaminants like oil, dust, sand, etc. And also the road elements themselves, right? So at intersections, we are going to have a lot of traction forces and standing traffic. Therefore, there will be chances of having smoother aggregates. Therefore, the friction will be lower. Also on curves and also bridges. So single spot measures or intermittent measures like lock wheel testers might not capture the true characteristics of the entire roadway, and we might miss some critical aspects, which I'm going to demonstrate using a small graphic over here. What you're seeing in the red right there is what if we had a data with continuous friction measurement, which might have some good high points, and then also there will be certain low spots. Now, God forbid you go ahead and take this single spot measures in those good high spots, you will end up having the impression that the friction is good, right? So to avoid these kind of black spots or low spots, we need to have certain continuous friction measurement. Now, one type of that I'm going to discuss today is fixed and variable slip. So what is variable slip? It can measure friction coefficients over the entire slip range, right? Over 0%, which is zero lock condition, to 100%, that is fully lock condition. And fixed slip, that is more popular, is it will measure friction coefficient at a certain fixed realistic slip percentage. What is a realistic slip percentage? Let's say we all have cars which have ABS system, right? Anti-lock braking system nowadays. And anti-lock braking, they operate anywhere between 10 to 30%. So in our study, we took 20% as a fixed slip value, and we calculated our friction coefficients based on that particular value. So to use this, we did a pilot study, thanks to MOTH and NHAI for providing the required permission for this. We tested them at 5 locations across the country, and we got incident data reports from MOTH and NHAI for 2 sections. One is in Araku, Andhra Pradesh.
Akshay, another 3 minutes. 3 minutes.
And Farrukhabad in UP. Okay, so we did continuous slip testing over here, and also we conducted them at 3 other locations across the country in Gwalior, Nagpur, and Siddipet in Telangana. One thing I just wanted to mention, the Nagpur section was on the Samruddhi Mahamar, which is a rigid pavement. And what did we do next? We compared the data with single spot measures like sand patch test and British pendulum test, and we tried to look at some correlations. So these are the side sections. I'll just skip. The study methodology, fairly simple. Measure it using continuous friction devices, measure it using spot measures, and then do a correlation analysis to see what it looks like, right? So let's look at first the data from the fixed slip tester. Okay, so this is one of the good sections. You have very good data. More than 0.5 is the friction coefficient and well above average. But the reason why we need continuous friction data is for what you are seeing in the slide right now. So this is a section in Farrukhabad. So you have some good friction values, and suddenly you have a drop in friction values. Now this is the reason why we need continuous friction data to spot low points, something like this. Okay, and once we get this data, we can always export it to a KML file, and we can do a beautiful beautiful Google Earth plot like what you're seeing here, highlighting all the good spots and the bad spots. So this is the data in a tabular form. I'll just skip for lack of time. And let's look at now the data from the sand patch test. So again, we did sand patch and British pendulum test. This is the data from that, and let's quickly move on to the correlations. Now, when we looked at the correlation between fixed slip testing and British pendulum test, it looked very good except for one particular anomaly. And we tried to look at what the anomaly was, and what found out was there was this one section which was very sandy. Now, fixed slip tester picked it up, but British pendulum test did not pick. It was still reporting good values. Now, the reason is if you have done British pendulum test before, you will realize that you have to clean the surface very nicely before you do the test. That's why sand was not present over here. So, if you remove that anomaly, you will see that correlation of 0.9. You will take it any day. So now coming to the relationship from friction to texture. So you have two relationships over here. One on the top left is showing you the one with fixed slip testing. Then on the bottom right, you're seeing one with British pendulum test. British pendulum, both are pretty much in the same direction. That is, if you have a good texture, you are pretty much having higher friction values, but British pendulum has a slightly higher correlation. The reason for that is if you see the British pendulum test, it is little sensitive to macro texture, which is exactly what sand patch test measures. So therefore, the higher correlation explains it. Whereas fixed slip testing or variable slip testing, they are sensitive to micro texture, that is the texture of your aggregates. Therefore, that explains the lack of good correlation, but overall pretty much in the same direction. Now coming to the findings from the study, continuous friction measurement, it is an invaluable tool, especially if you want to find these low spots. We did use a fixed slip tester which can isolate these low spots as well, and also it demonstrated good correlation with single spot measures like British pendulum. Now what are the benefits? Again, if you have any slippery roads, wet skid incidents that are occurring, you can identify them. You can enable texture restoration even before a crash occurs. It will allow you to map safety critical zones, and more importantly, it will help you in planning for your PMS or your asset management system. It will be a very nice input into your asset management system. And our recommendation personally is at project level, at least if it can be incorporated, similar to what we are currently doing for IRI monitoring, it will be a very good thing for our highways, and it can be an essential component of road safety audit as well. Thank you very much for your time, and I thank IRC for providing this platform and the opportunity. Thank you very much.
Thank you, Akshay, for an excellent presentation. We'll give a good round of applause to you. Thank you very much. So now we'll take up some questions. Delegates who would like to give, ask for any clarification, you can ask from the any of the four presenters or a couple of presenters, and identify yourself before asking the question. Thank you. Mic दे दीजिएगा.
Can we please provide a mic to the audience? So please keep that mic with you. We have another one, yeah.
Hello.
So, if, yeah, kindly.
Yeah, I'm Dr. Sandeep from the Institution of Engineers. My question from representative from BITS Pilani. How much time does it take to complete a test for, say, 10 kilometer stretch of road?
Sir, if I understand your question correctly, it is how much time does it take to test 1 kilometer of a road?
Right.
Okay, so the continuous friction measurement device can move at highway speeds or posted speeds. If you want to go at 60 kmph, you can go at 60. If the posted speed is 80 kmph, you can go at 80 kmph as well.
And how far is the penetration of this technology in this country? Whether this is first time this is being done or it is already established thing in India?
The variable and fixed slip devices, they are not yet completely penetrated. So this is something new that we are trying to bring into the country.
Nice. I congratulate you. Keep going on. Thank you.
Thank you.
Yeah. Any other question? Yeah, please.
Hello. Good afternoon, sir. Myself, retired chief engineer, Works Department, Odisha.
Sir, can you be please little louder with the mic? Can we please increase the volume? We cannot get him.
Mike,
Yeah.
pass my
Sir, put it little closer.
No, keep it near to your mouth. Yeah, it's working fine.
Hello. Good afternoon, sir. Actually, myself, a retired chief engineer, Works Department, Odisha. Actually, my concern is about the SP37 regarding that modification that is needed here. So can you please tell me those conditions where it can be affected for the daily works here, because it's under process of investigation, like raising of temperature and other factors are there which affecting this SP37 for design of the road crust. So just enlighten me on that regards.
Talking about drainage or durability. You're talking about durability of the payments or what?
Yeah?
Question is durability.
No, regarding these factors which has not been considered in our revised IRC SP37 2018.
Okay.
Now,
Some of
regarding
the factors I already told that one is about the top-down cracking.
because at our present systems of working, actually we are not considering all those aspects. So how can you get it, because all these ongoing works and designs are going on. So can you kindly light something on these issues?
Yeah. So already there are suppose top-down cracking. So they ask us to use some hard bitumen and all. But the actually work to actually address the top-down cracking, etc., are not being addressed. So that we are trying to address in the new guideline, top-down cracking. Similarly, rutting is only now we are only taking the subgrade rutting is the criteria, but rutting can happen in other layers also. So we are trying to even model those things also and integrating in the thing. And also we are trying to collect the temperature data.
Temperature, yeah.
Temperature data, which is also, we are verifying the existing models and also trying to collect data and also integrating that. Moisture is also being integrated. How the effect of moisture will be there in the design. All these aspects will be addressed
and
in the design.
intermittent conditions like sudden rainfall or sudden there is any rise in humidity, all these things also will affect the design.
Of course, that
Of course, no.
cyclone and all those things are not considered, but other aspects are considered.
Regarding temperature and all these.
Temperature, yes, temperature we are considering, and moisture also we are considering.
And how
top-down
far,
cracking,
No,
and even roughness is also being integrated.
Sir, EPETL will consider all these new changes. Actually, what is the deviation? What exactly we are practicing now without these parameters? How far it will affect the design?
That we have to see actually finally when the guidelines comes now. We have to see how. But what we are trying to do is some of the failures which are not
due to this.
addressed. Normally in any payment design, whatever the failures which are likely to occur, that we need to address. So some of these failures are not addressed, So those things we are trying to address, and also collecting a lot of field data.
Sir,
Almost
excuse me.
100 road test sections, data is being collected, cores, all these things, and we are testing, all these things are
Sir,
happening.
one more question, sir. In the absence of all this data, can you assume something in addition to the original design?
Can you reduce means?
Because if in the absence of this data, wherever readily it is not available, can you put some percentage of this quantity that can be added to our design?
No, that is, of course, that becomes
It is a
non-technical actually, but like increasing, decreasing and all. But there are few things which we have added recently. For example, when you want to have a, like, you want to reduce the thickness of, let's say, the DBM layer, we have recently brought a guideline like high performance binders have come up. So that guideline can be added. So things are happening, but this is like something holistic we are trying to address. Because after 2000, of course, this data is also very old.
yeah.
So Professor Veer Raghavan and their team, it long back, 1990 data only we have collected. Now we are trying to collect the data from different sections and trying to integrate, and so that the design becomes little like improved. Okay.
I'm really concerned about all these changes that will be affect the design, but I will request to the IIT in Kharagpur sir and all their teams, at least they should give more study
No,
on
even
this.
now, when this, I was discussing also, when this project was conceived, then we had a feedback section also.
Thank you, sir.
feedback.
Thank
We took a feedback from different agencies,
Yeah.
like practicing engineers, consultants. We heard from them
Thank
what they want.
Thank
So some of those factors also integrated, and we are trying to address them also.
Thank you.
So feedback also we took. Thank you.
Thank you so much. So, ladies and gentlemen, any other question? Please raise your hand if you have, please. Can we please pass on the mic to the back side? So kindly switch on your mic.
Good afternoon. Myself, Dr. Rajiv from CRRI. My question is from the presenter from the GGBS. The production of the GGBS in India, it is around 5 to 10 million metric ton only. And cement demand is around 450 million metric ton, right? So it's a very less amount. And if you will see, it is coming from the blast furnace slag, right? So whatever the carbon credit which you are counting there, the production of the steel and slag. So if you take the carbon credit from there, so are you feeling that it's a sustainable material? If you will include, because that whatever the slag is coming, it is around 1500 degrees Celsius, right? So huge amount. So almost 10% is coming from the slag, right? So if you will count their carbon credit there, and if you will include in the production of the geopolymer concrete, so do you feel that this is the sustainable material?
See, what I understand in your question is how sustainability is addressed when we are getting slag from a distant place.
Yes, because you have mentioned that it is a sustainable material.
Yes, yes. It is definitely a sustainable with the kind of quantity of slag which is produced in the country. And the issues of disposal and the reuse of this material can, because of its pozzolanic action, it can very well be used as a replacement to the cement binder. So that is what we are looking at. In the process, the slag is produced, and that cannot be avoided. In the process of iron and steel, the slag is produced, and the different fractions which are coming out are used for different applications and can be effectively used for pavement applications as well.
No, have you measured how you can quantify that it's a sustainable material? Like for example, GGBS, almost 50% it is utilizing as per the data, right? So GGBS, it's not the free available material, right? There is a cost. If you will include the cost, if you will include the production emission, right? If you will include the NOH, whatever the active alkaline material you are using. So if you will include everything to produce the geopolymer concrete, so do you feel, have you measured it is a sustainable material?
Yeah, see, he is asking, it's if you try to do a life cycle cost analysis of availability of GGBS is scarce. That's what his claim is. That being the case, is it affordable to do this kind of replacement? Is it worth to try? That's what he's asking.
See, we have to make a beginning somewhere by using the waste material generated, and this is a preliminary study, and we have a long way to go. So this is a trial which we have tried to replace 50-50 and as well as GGBS as a whole. And if it is providing promising results, I think why not for it? Why not go for it? That is a preliminary study.
In India, this study is going on several institutes is doing since last 20 years, right? And they have filed the patent also. Many institutes has filed for the geopolymer concrete, right? Mainly for the concrete for the building construction and the low volume, right? In the pavement part, so how you looking for that it is going to be work in the pavement engineering?
We have to try various combinations and see that we can, even the alkali activators, if we can do some kind of a combination which will be economical. There is a lot of study involved in this, and going ahead, if we get a research project on this, definitely we'll want to look into how in the life cycle cost we can make some kind of sustainable benefit for the construction industry.
Okay, thank you.
Okay. Last question we're having. All right.
Hello. I'm Chetan. I am from WRI. We work on road safety for a few years now. My question is to the BITS Pilani team. When you were mentioning about the road surface friction, right? And you showed some of the samples. So in the stretches like we saw, there was a lot of red sections where the slipperiness of the road is much higher. Did you correlate that with the road fatalities in all of the pilot sites that you chose? Because there could be higher chances that even with friction, there are fatalities happening on those stretches. So what was that correlation? How many percentage were happening on the slippery section and how many percentage were happening on the red section? Yeah.
Okay. Can't see you. Okay, so the question is, when we plotted the data, did we see what are the percentage of fatalities in red zone versus the green zone? Okay, so what we plotted there was basically we took the entire package, and based on the continuous friction data that we got, we segregated the data, whatever was, we set our own limits, right, 0.3 or 0.4, and whatever was higher than 0.3, we gave it a green color, and what was less than 0.3, a red color. So what you're mentioning about the fatalities, so we took the fatality data and then we came for friction testing, not the other way around. So this was a pilot study that was done because there were fatalities on those sections, and therefore we had to do over here. And I'll just give you one example. So we were given reports on Araku as well as Farrukhabad. In Araku also they mentioned the same thing, there were fatalities likely due to skidding. But to a surprise, when we went there, the Araku section, both the packages, they ran one of the highest friction data that we did in the entire pilot study. So that basically tells us that not all skidding accidents are primarily related to friction itself. There might be driver behavior, whatever other reasons. But in Farrukhabad, yes, we did see a lot of low spots in Farrukhabad, mainly due to polished aggregates, sand being present on the roads, which kind of also explains why there could be skidding related incidents over there.
Right, so in that case, when we look at your study, in stretches where there was high friction and other possibilities of reasons for fatalities, what could be your suggestion of looking forward to? Because I think one of the points that other person asked you was, if we do it or scale it across India to larger extent, what could be the risk potential to understand other factors versus the friction factor just as a cause of fatalities?
I mean, from what I see over here, it is, I mean, why are we not using the technology is my biggest question, because what I can see over here is only the benefits. Yeah. I mean, currently if we are just using a British pendulum test in order to for a 50-kilometer stretch or a 25-kilometer stretch, if you're just relying on one point measure for a
Yeah,
friction,
Akshay, can I add on to this? See, for the question what he is asking, you cannot try to isolate only the frictional factor as the primary reason. You need
Absolutely
to do a
correct.
FIR analysis and come out with the
Correct.
multitude of factors could be there. So you are supposed to understand it, and you have done it on one pilot section. With that, we cannot make a final
No, that is absolutely
conclusion,
correct, sir.
inference based on that.
There might be many reasons for
That,
why.
just you have to keep that in mind. That's what other factors have to be taken on board from your FIR data. That's what.
Definitely. I was just responding to his question of what could be the potential benefits. So my idea is
No,
why
he's asking what factors, other factors he's asking. What other factors, what influence?
was that your question? You were asking about other factors.
Influence
It's a
of
combination
other
of both. It's a combination of both, wherein the scalability as well as incorporating other factors and trying to see the percentage of affection of either side.
Chalo, we are running short of time now. We'll just conclude it now. And so we will whoever want to have any further interactions, we can have it during the tea break because organizers want to conclude it at the earliest. So we had an excellent gamut of presentation, though a couple of presentations are outside my ambit of things. And actually, I found it quite interesting. Some of the study, especially the one by IIT Kharagpur on improving the IRC 37 on the lines of R6 study. They are doing an exhaustive study. Hopefully, IRC 37 will have a rejigged version, what Professor Amarath Reddy told, will be presented to the same IRC web in the coming 2027 or 28. And we had an excellent presentation by Bijli Balakrishnan on structured evaluation of UHP FRC. In this, CRRA also has worked some time back on this. And I nice to see Bijli Balakrishnan is, with her team, she is trying to come out with the things. Hopefully, IRC document will also get benefited in this regard. And the safety presentation by BITS Pilani team has won a kind of good deliberations we had. Hopefully, this is one of the very unique attempt made by the BITS Pilani team to do this thing. And I hope we will be able to come out with much more interesting results to contain the fatalities. And last but not the least, this GGBS and fly ash thing, that is also one of the need of the hour. So that way we had a good presentation. I would like to thank all the presenters. We give one big round of applause to each one of them. Thank you.
Thank you so much, sir. It seems like that we had a very interesting and insightful technical session. But for now, may I kindly request our chairperson of the session to kindly give his concluding remarks, please, sir.
Continuing with the very interactive session, innovative presentation from the academic session, as Madam said, is just a beginning. There where it needs to be brought on the field, and there is a lot of difference when you bring it on the field. The exact thing what you do on the field, being a person on the field, really gives the results, and that's why the data collection on the field is very, very important. Coming to the first presentation of performance-based concrete by Dr. Bijli, the extent of percent of fibers, the percentage, type, makes a lot of difference. And it's in the inception stage, and I'm very pleased to see that in Tirupati you have something to test your girders. And I feel that should go to the commercial length, which is generally around 30 meters and beyond that. But you have started with 22. It's a very good sign of that. Coming to the second presentation, which speaks about the evaluation of IRC 37 from 1970 till date. And then 4 big institutions joining hand to give a definite shape based on the practical field experiences. It's really encouraging. So they deserve a lot of credit for that good presentation. Coming to the third presentation of binary blend of geopolymer, innovative idea, because we have to make a beginning somewhere to see that whatever is there, how best it can be used and how the carbon footprint can be reduced. Coming to the measurement of your roughness, the friction is one of the factors which results in helping you to identify which are the stretches which can be taken up for resurfacing. And I think other factors also can be taken into consideration. So altogether, it was very, very good interactive session over here. And as I said, I'm privileged being an academician and a person on the field doing both the roles. So I wish them all the best in future endeavor. And I conclude the session. Thank you.
Thank you so much, sir. Now, as a token of our gratitude and appreciation, now it's time to present the mementos. And to do the honor, may I request Sri Uttam Parsikar, chair of the session, to kindly present the memento to Dr. Bijli Balakrishnan, assistant professor, IIT Tirupati. And ladies and gentlemen, let's give them a round of applause. Let's give it up for Dr. Bijli Balakrishnan. Thank you so much for your lovely presentation. It was really knowledgeable. Thank you. Next, we are having Professor M. Amarnath Reddy, IIT Kharagpur. Thank you so much, sir, for your wonderful presentation. Next, we are having Professor Akshay Gundla, Assistant Professor, BITS Pilani, Hyderabad campus. Now I'm really delighted to announce we are having Dr. Jaya R. Shinganmakki, Professor, BMS College of Engineering. And along with her, Sri Manjunath. Thank you so much, both of you, for your very, very, very interesting presentation. And now it's time for our chairperson and co-chairperson. And now may I please request Sri Hiralal Agrawal, Chief Engineer, Works Department, Odisha, to please come to the dais and present a memento. First, to Sri Uttam Parsikar, Chairman of the session. And now it's time to felicitate our co-chair of the session, Sri Dr. S. Velamurgan. Thank you so much for your valuable time and the knowledge you have shared with all of us. Thank you. And now may I kindly request all the dignitaries on dais to kindly come forward. We are going to click a group photograph. Let the chairperson and co-chairperson be in the middle. And yeah, that's a lovely picture. Can we all clap, everybody, please? Thank you so much. Thank you. And we'll head for the next technical session, but Do we have a break or we don't? Okay. All right, ladies and gentlemen, we are going to have a tea break of 5 minutes. So you can have a tea, you can grab a coffee, and you can settle yourself once again. As we are running really late, we have to start it in time. So please go grab a tea or coffee. We are going to start the session after 5 minutes. Thank you. That's okay, absolutely fine.
Hello. Check.
रखोगे तब ये करेगा, RF के साथ कनेक्ट है। ये स्टेज से नीचे जाओगे ये कट जाएगा पर से, इसलिए वो टेबल के लिए है। हाँ
Check, hello, check. 1, 2, 3, hey, check.
Check. Check. Hello. Hello. Check. Check. Hello.
check, check.
Check. Hello, check. Check. Hello, check. Everybody, please settle down. We are about to start the next session. All right, I hope everybody had a cup of tea or coffee. Yeah, it was refreshing. I didn't have. I will have after some time. All right, so let's start. Once again, good afternoon, everybody. I welcome you to the technical session 3 for scientist officer from R&D organizations. The session will be chaired by Professor A. Veeraraghavan, former professor IIT Madras. I request him to please come on to the dais. And the session will be co-chaired by Shri Ayaz Ahmed, Engineer-in-Chief, retired PWD Uttarakhand. And now it's time to welcome our chairperson and co-chairperson, and to do the honor, may I kindly request on stage Shri Shubhranshu Sekhar Swai, Superintending Engineer, Works Department, Odisha. Starting with our chairperson of this session, Professor A. Veeraraghavan, former professor IIT Madras. Ladies and gentlemen, we can all clap for him. Next, as our co-chairperson, Shri Ayaz Ahmed, Engineer-in-Chief, retired PWD Uttarakhand. Thank you so much, gentlemen, for your valuable time. Now, may I kindly request Professor A. Veeraraghavan to kindly start the session. And before that, may I invite all the presenters of the session to please come to the dais. Engineer P. Elango, Deputy Director, HRS, Tamil Nadu, and J. Kavita. Dr. Praveen P.A., Scientist, and Shri Ashik K. Azad, Scientist, National Transportation, Planning and Research Center, Kerala. Dr. R. Manisekar, Senior Principal Scientist, Advanced Concrete Testing and Evaluation Laboratory, CSIR, SERC, Tamil Nadu. Shri Mahesh W. Kasture, BPCL, Uttar Pradesh. Dr. Irudaya Raj Devota, General Manager, Bitumen and Separation Process, Indian Oil Corporation, Haryana. Dr. Vinod Karar, Chief Scientist, and Mrs. Kamini Gupta, Senior Technical Officer, CRRI, New Delhi. May I please request all our presenters to kindly join us on the dais. And now may I kindly request our chairperson, Professor A. Veeraraghavan, to kindly start the session. And before that, there's a small announcement. Everybody, please put your phone in a silent mode. If your messages and calls are not that important, kindly don't take it. Let's start the session, sir.
Thank you. I think we have an interesting last session of the day. This session, technical session, is for the presentation by the scientists, officers from R&D organizations. We will have 6 presentations during this session. 4 of them are towards sustainability. 1 is on safety. The other is on bridges. So we'll have an interesting presentation by all the officers and scientists from the R&D organization. We'll interact and we'll learn in the process. To start with, I also thank Sri Ayaz Ahmed, Engineer-in-Chief retired from Uttarakhand, who has been here with me to co-chair the session. Do you want to say anything?
Yeah.
Myself, Ayaz, I'm a retired engineering chief, PWD. Actually, it is my privilege to co-chair this technical session. I hope all the presentations to be presented over here will be a insight view for the entire engineering fraternity. Thank you.
Thank you, sir. The first presentation is on enhancing durability and environmental sustainability of clay soils with geopolymer stabilizers in highway construction by Engineer Ilango. May I request Mr. Ilango to share his research work.
Respected Chairman, Co-Chairman, distinguished delegates, esteemed researchers, professors, experts, and engineers all over the world. Good evening to all. It is an honor to share our ongoing research work at Highways Research Station, Chennai, titled Enhancing Durability and Environmental Sustainability of Clay Soils with Geopolymer Stabilization in Highway Construction. Soil stabilization is a critical technique in geotechnical engineering to improve the physical and mechanical characteristics of problematic soil such as clay, which commonly exhibit low bearing capacity, high plasticity, and volume instability. Traditional stabilizers like ordinary Portland cement have environmental and durability concerns, prompting the exploration of sustainable alternatives. This study investigates the use of GGBS-based geopolymer as an eco-friendly and high-performance soil stabilizer for clay soil. Geopolymers are alkali-activated aluminosilicate binders synthesized from industrial byproducts activated using sodium hydroxide and sodium silicate solutions. Laboratory experiments were conducted to assess the effect of geopolymer stabilization on key geotechnical parameters, including liquid limit, plastic limit, free sol index, maximum dry density, California bearing ratio, and shear strength. Varying normalities of alkaline activators were used to optimize the geopolymerization process. Additionally, scanning electron microscope and X-ray diffraction analysis provide insights into the mineralogical and microstructural transformation in the stabilized soil. Now I invite geologist Kavita for the presentation of the research work. Thank you, one and all.
Roads are the very important national development. They are called backbone of the nation because they help people Subgrade soil is fundamental factor in highways construction. It has to support weight of the structure. The most important factor is influencing pavement thicknesses CBR, and this is measured by, in some cases, low CBR is not, In some cases, good CBR soil is not available in the field. We encounter with low CBR soil. And this type of soil is not suitable for pavement construction and design because they need higher pavement thickness and higher construction and also require bitumen and aggregate resource. There are most of methods available to improve the strength of soil stabilization. But this study focuses on the soil stabilization. There are two types of soil stabilization. Mechanical stabilization like compaction, preloading or using geogrid material. Chemical stabilization, additives like cement and fly ash. Advantage of stabilization is reduced construction and maintenance cost and reduced environmental impact. But some demerits of traditional stabilizers have. They causes pollution, they need more energy and can causes crack and require more curing time. One such stabilizer is geopolymer. Geo means earth, polymer means many. The word geopolymer introduced a French scientist, Joseph Davidots. She is geopolymer father in concrete. It is formed by chemical reaction between aluminosilicate material such as fly ash, metagylene, and alkali activated solution like sodium hydroxide and sodium silicate. There are 4 stages in geopolymer process. Dissolution. This alkali solution breaks the raw material and release alumina and silica. Second, depolymerization. This material become free and more active. Third, polymerization. This alumina and silica form gel. Fourth, hardening. The gel become hard and dense like stone. It is called geopolymer. Methodology of in this study, selected low TBR soil, added stabilizer washed 10 to 40% by weight of soil, and then alkali water is added. Then after, the sample kept cured for 7 days curing, and the 5th day from the date of stabilization, the sample was tested. Objective of in this study, improve the strength and durability of stabilization, validate geopolymer as a strong and eco-friendly alternative to traditional cement and lime stabilizer in highways construction. This slide shows the geotechnical properties of natural soil. In this study, used GGBS as stabilizer. In this study, used sodium hydroxide and sodium silicate as alkali activator. This solution helps to the strength gain of the soil. Preparation of the alkali activator. First, sodium hydroxide is dissolved in water and then sodium silicate is added, then mixed well. The mixture is called alkali activator. This image shows how GGBS stabilized soil is prepared. This image shows the alkali activator added in stabilized soil. This graph shows the maximum dry density of soil. When we added stabilizer, it increased the dry density. The highest dry density around reached the 30% of stabilizer. This graph shows the optimum moisture content of stabilized soil. This graph shows the CBR value of stabilized soil. We can add stabilizer and alkali activator increases the CBR value. Reach the maximum at 20 to 30%. After increase the percentage, the CBR value start to reduce. This same image of natural soil, we can see the soil particles are loosely packed with many pore spaces. And these particles are small and large, irregular in shape and not well bound. This shows the natural soils have weak structure and low strength. This graph shows the element presence in natural soil. We can see the high percentage of oxygen and silica and small amount of calcium and iron and magnesium. This same image of GGBS stabilized soil, so the surface are dense and compact compared to the natural soil. The particles are partially fused and both reduced. After adding GGBS, the graph shows the increase the calcium along with the silica and aluminum. This indicates that GGBS had increased the calcium to the soil, which help in forming gel-like calcium halocate silicate, and it increased the strength. This image shows the highly dense and compact and needle-like gel structure spread uniformly. This graph shows we can see that high peaks of sodium and silica and aluminum calcium. This indicates that when GGBS is combined with the more gel-like sodium halocate silicate hydrate compounds are formed. These compounds are filled to increase the strength and stronger of the soil. Conclusion of in this study, the combination of GGBS and alkali activator effectively improve the engineering properties of soil. Same analysis confirmed the dense calcium silicate hydrate and sodium halocate silicate hydrate gel network, providing better interparticle bonding. The optimum dosage 30% GGBS with alkali activator giving maximum dry density and CBR value. Hence, the geopolymer stabilization using GGBS is sustainable and efficient method for soil improvement in highways application. Thank you.
Thank you, Kavita. I think before we move to the next presentation, are there any quick questions? One or two we can take. We need not wait till the last presentation to recall what Kavita presented. Any quick questions? There are no quick questions, at least I will ask some questions. Kavita, for a kilometer of a road, 2-lane to be constructed, what will be the quantity of geopolymer that is required when compared to the conventional method of stabilization for a clay, which can be a lime? What is the cost difference between the conventional stabilization with the lime vis-a-vis stabilization with the geopolymer? How much quantity of material will be required? What will be the cost?
So actually, this is the laboratory study, just started now. The 3 phases are there. First, we will do the exact technical aspects of the various components involved in the natural soil, GGBS, and activated soil. The second phase is the implementation in the field. And third one is the exact cost analysis, CO2 emission analysis, and environmental impact analysis. We will do it, sir, and we will report it in next IRC also.
As well said, it has enhancing the durability and environmental sustainability. Just it is based on the laboratory results, or has it been applied in field also? In which state and on which national highway or state highway?
Actually, we have the test facility in our highways research system. There is our old institution, 1957 it was started. We have the test track facilities where we can use the stabilization methods for the subgrade formation. And if possible, we can include the sensors, instrumentation, and detailed analysis for the real road network.
Thank you. I think there are a few more points that the team should consider. Number one, the title does not say it is a laboratory study. You should be very clear that it is laboratory studies on geopolymer applications for a clay soil stabilization. Second is about the property of soil with different dosages of GGBS and polymer should be presented. Even CBR, whether it is a soaked CBR, unsoaked CBR is not known. The repeatability, reproducibility, durability, long-term performance should also be reported, even in the laboratory studies. Yeah, thank you. Let's go to the next presentation, Bridging Research and Practice, NATPAC's role in shaping safe and sustainable transport by Dr. Praveen and Sri Ashik Ahmed. Who is going to present? Yeah, Hashik. Yeah.
Good evening, all. I think, okay. Respected Chair, Professor A. Veeraraghavan sir from IIT Madras, retired professor from IIT Madras, and co-chair Sri Ayas Ahmad sir, retired Chief Engineer, PWD Uttarakhand, distinguished delegates and esteemed colleagues. It is indeed an honor and great pleasure to represent National Transportation Planning and Research Center, my parent organization, under the Kerala State Council for Science, Technology and Environment. NATPAC has been founded in 1976 and has been at the forefront of transportation planning and formulation of policy since its inception. We have been providing technical support and scientific solutions to the Government of Kerala in the field of transportation. Since 1976, the Center has been handling research and consultancy projects as per the country's and states' requirements in various domains of transportation field. Since the time is very limited, we and my colleague will be briefly presenting 3 research projects which we had undertaken in the year 2025-26. One such project is, apart from that, we also undertake several training programs, knowledge dissemination sessions, and road safety awareness classes for young generations with a view of improving the road safety to the public. So, one project is the evaluation of effectiveness of traffic calming measures in Kerala. In Kerala, during the past several years, there is a tremendous increase in the number of accidents which has been causing in the roads. So, in order to reduce the number of accidents, several traffic calming measures has been introduced, including the transverse bar markings, speed humps, and speed tables. However, the efficiency of these traffic calming measures is hardly evaluated, especially for a state like Kerala. So this particular study attempts to evaluate the effectiveness of these traffic calming measures. So following are the major objectives. We also attempted to develop an empirical model for the speed profile of the traffic calm links for uninterrupted vehicles, and also to determine the effectiveness of TCMs using an effectiveness indicator. This particular study was limited to only the vertical deflection measures, such as which we mentioned just now, the TBMs, speed humps, and the speed tables. So the data was collected from 21 locations across Kerala, covering the southern, northern, as well as the central part of Kerala. The data which we collected includes the traffic data, and it was with the help of drone as well as videographic camera. And the data was analysis with the Kinova as well as the data from Sky Softwares. We found out that the traffic composition indicated about 50% of the vehicles was two-wheelers and 30% was cars, followed by the rest of the categories of vehicles. The speed profiles of the different vehicles was also plotted, and it showed that the speed of the vehicles on the downstream of the TBM has decreased about 40 to 60 km per hour, whereas in case of speed humps, it has reduced from 15 to 30, and for speed tables, it varies from 15 to 30 km per hour. Also, the crash data of the locations were also collected. The number of victims which get affected by the accidents reduced after the installation of TBMs and speed humps and speed tables by 45%. Also, the fatality rate has also been reduced to 50%. And to evaluate the effectiveness of the traffic calming measures, an indicator was also used based on the study conducted by Natalia Distinfanto. So this effectiveness indicator was used to determine the effectiveness of the traffic calming measures, reducing the speed at the survey locations. The speed hump and the speed table was found as effective. There was a range of values which has been provided in that, whereas a value less than 0.7 indicated as a very good thing, and a value between 0.7 to 1, it was having a fairly good, and greater than 1 was a poor criteria. And regression models was also developed for the speed table, speed hum, and TBM markings. And our conclusion of the study was, when compared with the effectiveness indicator, percentage reduction in speed and accidents, the speed table and speed humps are best suited for the traffic calming device. And for the school zones, the speed tables can be adopted for achieving adequate speed reduction rather than providing T-beams. So these are the most important findings from this particular study. The other two projects will be briefly presented by my colleague, Dr. Praveen P.S. Over to you, Praveen.
Okay. Good evening, all. So, I'll be presenting on this topic, like optimizing urban transit network using a multi-criteria approach. This is a project which is an ongoing project in NATPAC. So, here the main objective is to develop an optimized network design model for the public transport services considering operator, passenger and community interests. So basically, the study scope is limited to Trivandrum district in Kerala. So this pertains to the circular services which is being undertaken by the Road Transport Corporation in Kerala. So this is the available circular route services. Based on that, what we have done was we found out the catchment area, like who are the benefiting people around the 800-meter area along the circular service, where the people are willing to walk to the nearest bus stop and use up these services. And then to analyze these things, how the circular service is proceeding, the boarding and alighting surveys was conducted. And basically this is the boarding and alighting details of the passenger for each of the bus stops for a typical circular trip and not the entire thing. So we are trying to plot it trip by trip so that it will be easy to represent. So this is basically a trip odimetrics which was plotted using for a typical circular route. And the desired lines show are using the code diagram. Now the link volume or the passengers, how many passengers are getting loaded into the link during a typical circular trip is shown in this figure. Now once these basic data has been collected, we had to identify where the services are needed. And for that we used multi-criteria decision approach. And then for multi-criteria decision, we analyzed the different key factors. One of the factors is service area of the point of interest. That is basically the schools, hospitals, etc., where the people are willing to take up the circular routes. The next key factor was service area of the bus stops. Another factor was the road network buffer. The next was the population density, the area, how dense the area is so that they will be willing to take up the service. And the next one is land use, land cover thing. So basically this pertains to know where the people are dense and where they are going to take up the services and where they will be underutilized. So based on these key factors, these were weighted and analyzed using AHP, and the weightage was different for each of the different factors, and then weighted was overlaid on the ArcGIS, and finally we came up with an area public transit service map, that is the area requiring circular service. So basically what we found out was that highly recommended areas, around 29% of land area, the circular service was highly recommended, whereas 52% of the area, the service could be extended. And for 16% was very much less recommended, or it was not prior. Now, having the details, basic details and all, we decided to go in for a network redesign. And based on the objective functions, wherein which the passenger time and transfer is minimized. That was the first objective. First variable of the objective function. Second variable was around key factor was operating cost, minimizing the operating cost, and then the robustness or vulnerability. Even if a part of a service network is down, how reliable will be the remaining circular network? That was considered. And the next key factor was the equity and coverage. So that means the spread is uniform and it is accessible to all. Based on that, what we have done was we are trying to optimize the design and come out with a sustainable and more resilient network where it benefits the community and it will be also affordable to the service provider. So coming into the next project, which we will be discussing on the study on road crashes involving vulnerable road users with focus on pedestrian and fatal crashes. Here, we have found out that among VRUs, pedestrians are the most vulnerable or more critical. So the scope of the study is limited to the pedestrian crashes which has been repeated along during the year 2018, 2019 and 2022 in Kerala, and we have left out 2020 and 21 data due to the COVID scenario. And the objective was to demarcate the pedestrian vulnerable corridors in Kerala and then to develop prediction models for pedestrian crashes, then to derive a methodology to establish a new vulnerability index, that is a pedestrian vulnerability index. The map shows the pedestrian crashes which was collected from the FIR data. And coming into the data collection and analysis part, the specific sections of road that pose increased risk and safety concerns for pedestrians were identified, and these corridors were characterized by conditions that make walking more hazardous, and there is a more likelihood of pedestrian-related crashes. And this was done extensively across the state along 14 districts, and it was found that the first figure shows the crashes, pedestrian crashes, and the second figure is the corridor level thing which was developed. So we found out that Ernakulam is the district which has the highest number of corridors, whereas Trivandrum was second and Kozhikode was third. So instead of focusing on a particular point, we are trying to come up with a corridor where the pedestrian crashes are frequently occur or pedestrian will be more vulnerable. So finally, the output of the study will be the development of a pedestrian vulnerability index, which will be a quantitative evaluation of the safety condition for pedestrians on a particular stretch. So it means that finally it will quantify a vulnerability of the particular location. Once we have this value, we can tell that if the vulnerability value is a particular value, and we can tell that if particular stretch is safe for pedestrian or not. So finally, the output will be the creation of pedestrian-friendly environment and encouraging active transportation, which leads to healthier and more sustainable communities across Kerala. Thank you. Thank you all.
Thank you, Praveen. Any questions from the audience? Any questions? Maybe one or two quick questions. If there are no questions, then again from the stage. I think, Ashik, you talked about this comparison of the transverse bar marking, conventional speed humps, and the speed tables. When you try to compare what was the thickness and the spacing of the transverse bars, because I found that plays a very important role. The spacing and thickness that matters for a four-wheeler does not matter for a two-wheeler. So how did you consider for different speeds? That's the first question. Second is that IRC 99 gives a different width of speed humps depending upon the desired speed. But you have considered what width in your study? How did you compare the repeatability, reproducibility, sample size to draw conclusions?
Sir, your first question was on the TBM. It was really a concern for us because in Kerala, in different locations, the spacing as well as the width, it varies. In some locations, 4 TBMs, a series of 4 TBMs has been provided. In some locations, a series of 6 TBMs has also been provided with a gap of 0.5 meter and thickness of almost 30 centimeter, 0.3 meter was there. And also for the speed tables, speed humps. The second part was on the speed humps. The width of the speed humps was from 0.4 meter to 0.5 meter. It wasn't varying at these locations. So the uniformity in case of this TBM as well as speed humps was not observed in these locations. However, the locations which we considered for these 21 locations, we tried to make it, we selected those locations which are on a uniform nature. So accordingly, that study has been conducted, sir.
Okay, fine. Thank you. I think we should also supplement with the statistical significant tests.
Yeah.
Whether statistically the values are different, significantly different or not. For further studies.
Okay.
Yeah. Okay.
Yeah.
The other is on the Praveen, what is that optimized network? What do you want to optimize? How did you validate your optimized models? Secondly, the number of pedestrian fatalities, you did not mention how many years. It's a 3 years data, 1 year data is also not known. Third is about vulnerability index. In all these indices, you will find that the factors remain constant in future also. They need not be. So these are the limitations that you have to consider. If you want to respond anything, you can tell. Yeah.
So,
right, sorry to disturb you. As I think this is the topic which resembles with the road safety also. Road safety measures and traffic calming measures. How to choose the area having requirement of services, network, of this network. How will you choose that this area required this network?
Sir, it was based on the, we studied those locations based on the accident data as well as the FIR data which has been collected from the police department. So those locations has been identified and chosen based on the number of severity of accidents. Fatal crashes are there, the more fatal crashes was occurring at those locations. And when they provided these traffic calming measures, it was observed that the fatality rate as well as the number of injuries has been decreased. It was based on the accident data, sir.
Thank you. Kini, what other factor that you should consider is that we do a post-mortem after the accident occurs. What we should do is that preventive measures based on the speed we should be able to arrive at and then find which is the optimal combination of transverse bar markings, speed humps, and the speed tables.
Definitely, yeah. Sir, definitely.
Thank you. I think that's enough. Third presentation is on the experimental investigations on the ultimate behavior of PSC box girders and monitoring of priestess by Dr. Manishekar from ACRC Chennai.
Respected chairman and respected co-chairman and respected delegates. My good evening to one and all here. My presentation is on experimental investigations on the ultimate behavior of PSC box girders and monitoring of priestess. The first part is on that is experimental investigations and the second part is monitoring of priestess. Yeah, in behavior of box girders, in brief, is a simple beam action and torsion due to eccentric loading, distortion due to eccentric loading. Actually, in simple beam action is in analysis, the plane section remain plane even after bending is working. And if you come to the torsion is due to only the eccentric loading, and because of the torsion and the plane section remain plane is ruled out. And out of plane deformation is rules the analysis. And also in the distortion is also due to the eccentric loading. And here in the distortion is also the plane section remain plane is ruled out and out of plane deformation rules analysis. And here coming to the box girder, inside is a hollow. So in analysis, it is being treated as a thin walled structure. Thin walled structure means the inside hollow portion is bigger than the outer wall area. The next is, this is the experimental investigations on the PSC box girder. Coming to the design, and if you see the literature, you know, all the box girder literatures are below the 5 meters. Therefore, SARC as a national laboratory, we have taken 6 meter length. That means span 5.6 meter length we have taken span. And this is the section of the midspan section. You can see the reinforcement detailing. The size is 700 mm by 500 mm. The inner section is 560 and 360 mm. Thickness is overall uniform thickness 70 mm. And this is the, as it is a midspan section, and this two are the parabolic tendons, and these two are the parabolic tendons. All the 5 tendons, precessing tendons, are the straight profile. And coming to the next, this is the reinforcement detailing at the end section. So, as I said earlier, totally 9 tendons. 4 tendons are parabolic. These 2 in one web, another 2 in another web, and this bottommost 5 tendons are the straight profile tendons. This is the casting of concrete box girder specimen. In the casting of bottom flange, you can see the reinforcement, and this is the parabolic profile, the top one, and this is bottom is also the parabolic. And after this, below there is a straight tendon is here. So 1, 2, 3, 4, 5 tendons are the bottom. Bottom tendons are the 5 straight profile tendons. And here this is the casting of bottom flange concreting. And coming to the next, the casting of webs at the 2 part. This is one web and this is another web. That casting of concrete is, it is there. And next, the casting of the top slab concrete by putting the formwork. And this one is the casting of end walls. And the next is coming to the post tensioning, because already the casting is over. Post tensioning is the first placing the concrete and then doing the precessing. Precessing, it is the post tensioning work. And this is the 13 tons force as per the design, 13 ton force provided to each tendon. The tendon force, this is the, so I would like to, attract the audience that this tendon force were monitored by attaching vibrating wire load cells at the end plate. Because presently the precessing force is not being monitored in our laboratory. The precessing force were monitored from the initial precessing stage throughout the end of the test. That means the failure of the box cutter member. And this is the load cell, vibrating wire load cell, and this is, and from here the lead wire is coming. From the lead wire, it will be connected to the data taker, and then it is connected to the laptop, so that throughout the loading, the precessing, the initial force we are giving 13 ton force. The 13 ton force will be increased in the duration of the loading. So that all will be monitored till the end of the test. So next, this is the testing, and this is the 200 ton actuator. The 6 meter length box girder is being tested. And here, coming to the instrumentation, the bottom tension reinforcement is being instrumented in the constant bending moment region and the beyond the constant bending moment region. Therefore, the tension, the strain in the tensile reinforcement, that is only the tension reinforcement only giving the behavior of any concrete members. So that is being monitored by proper instrumentation in the tensile reinforcement. These are the almost 24 strain gauges. And this is the failure of the box girder member by concrete crushing at the top fiber. The failure of any member is the concrete crushing at the top fiber. So if the concrete crushing happens we should stop the loading. That is the failure. So if the failure is here. It failed with the 78 tons, 765.5 kilonewton with the 37.8 mm deflection. The failed due to concrete. The failure occurred at front web. As I said earlier that it is a thin wall structure. There are two webs. One is front web, another one is the rear web. So the failure will happen only at the either of this web or that web. In this case, the front web, they failed. And coming to the results and behavior, this is the load deflection behavior. And the maximum load, 765.5 kilonewton, and maximum deflection is this one. And this figure is the very important figure. This delta PS is the stress increase in tendon. This picture was possible only because of monitoring the pre-stress by the vibrating wire load cell. That is a very important one. So the front web is failed. So in the front web, bottom tendon is straight and the middle tendon is parabolic, top tendon is parabolic. So accordingly, the delta FPS is plotted, load versus delta FPS, stress increase in tendon is plotted, and the maximum stress increase in tendon is 315 MPa. So that is this is possible. This picture is possible only because of the monitoring the pre-stress by vibrating wire load cell. And this is the, as I said earlier, in the strain in tensile steel in the concrete. So here this is the result. The strain at a decompression load. Decompression load is the first crack load, that is a decompression load. That happened in 490. The corresponding tensile strain, the tensile strain corresponding to decompression is 1118 microstrain. So also it is called as a 0.0011 strain. The strain at yield is 2054 microstrain. Strain at failure is 3604. And this is the picture of the concrete strain. The concrete strain is concrete strain is pasted at this 1, 2 and 3. These two are the 2-point load, one another here, and this is the mid. So 3 concrete strain gauge, 6 mm strain gauges were pasted, and it was also monitored. So this is this one. So here at decompression 994 microstrain, and at yield this is the 1500. At failure this is this one, and this is the conclusion. The first crack occurred at 64% of the ultimate load, and the decompression occurred. The tensile steel yielded at 79% of the ultimate load. After the specimen reached ultimate state. Stress increase in tendon, the delta FPS, started increasing after the yielding of the tensile steel. The box cutter specimen failed at 7010 and with the maximum load of maximum deflection of 37.8 mm. The failure occurred by concrete crushing at top fiber of the front web. The specimen displayed plastic hinge before failure and ensured ductility. If there should be a ductility, the plastic hinge should occur. Then only the ductility will be ensured. Though in this case, the ductility is also ensured. So the vibrating wire load cells were used for monitoring the pre-stress. This was successful in the lab and facilitated to observe the stress increase in tendon delta PS. The maximum stress increase in tendon delta PS was observed as 315 MPa. This occurred in the web that displayed failure, that is front web. Also the decompression yield failure occurred at the web that displays in the same web. And the behavior, the ultimate behavior of the box cutter specimen under static monotonic load has been predicted in the stages: decompression, yielding of tensile steel, stress increase in tendons, plastic hinge formation, and failure by concrete crushing at top fiber. And the next part is the monitoring of pre-stress in PSC bridges using load cells. This is as a separate part I would like to present here. Now, the loss of pre-stress from the bridge field, from the industry, what it is observed, what it is reported all over the world is loss of pre-stress is one of the main sources of distress in PSC bridges. So the pre-stress are stress in posterior tendons presently not being monitored. In any bridges, it is not being monitored presently. This leads to lack of noticing the loss of pre-stress and losing the stiffness of the member and load carrying capacity, and this lead to sometimes it failed. Some bridges fail without giving any warning, and also The effective precess FPE is also not known. So for example, a few reports from the field is, from the Italy, this bridge is reported as 60%. In India, Azwari Bridge, Sharavati Bridge, 50 to 28%. And the Airport Express Highway, it has become 23% loss of precess. So in general, all over the world, the loss of precess in the range 15% to 60%. So there are SHM, structural health monitoring in the bridges. At the time of construction, the sensors used to embed in the various locations in the concrete, and the bridges are being monitored. But it is very few only. So far, the ITO Bridge, New Delhi, Ganga Bridge, Varanasi, Mandey Bridge, Goa, Airoli Bridge, Thane Creek Bridge, Mumbai, Pamban Bridge, Rameswaram, Yamuna Bridge near Delhi. These bridges only were monitored. And this implementation all over the country is, the consensus is not arrived. Therefore, the monitoring of the precessing is required. So the importance of monitoring of precess in existing bridges gives a clear roadmap for retrofitting of bridges. Based on the amount of loss of precess, the bridge engineers can judge the distress of the bridges and hence avoiding further distress. Then, expenditure of retrofitting can be reduced since the distress detected at the initial stage itself. So coming to the lab research, in our SARC, we have done the 20 tons load capacity like this. This is the side portion and this is the front portion. This was successful.
Manshekar, there are 3 more presentations. You have to conclude here.
1 minute, sir. And this is the TRL London, Transport Research Laboratory London. They have taken 20.25 meter span was tested using the load cell. So the rough estimate. So definitely there will be a question. What is the estimate of this one is less than 1% of the total estimate cost of the bridges. So the main advantage is it gives an accurate measurement since the stress in tendons in between the anchorages are always constant and does not vary. Stress in tendons can be measured directly and instantly. Cables which have loss of precess could be identified. Since the load cells are attached at the ends of the girders, they could be easily accessed through piers for monitoring. So the recommendations from the lab research is this: load cells need to be attached at the PSI girders, in situ box girders and segmental box girders of all the bridges to be constructed in future to facilitate for monitoring of precess. It may be implemented in a pilot bridge. Spending 1% of total estimate cost for load cells is most economical rather than spending 15% for retrofitting when no monitoring is done. So I would like to finally say that, from SCRC, we are in the process of monitoring the precess in the real life bridges also. It is in the process. Thank you very much.
Thank you. Are there any questions from the audience? It is an interesting presentation. Yeah. Can anybody give a mic? Yeah, she is bringing the mic here. Yeah, you can read the question and answer. Yeah, please. Yeah.
Yeah, he has asked the questions from how to fix load cells to old 45-year bridge for post-tensioning. It is a good question, sir. I have not told this. For the existing bridges, it is not possible to install because before the precessing, there is a wedge barrel is there. Before the precessing equipment only, the first placement of the first placement is the load cell. Afterwards, the wedge barrels. Then we have to do the initial precessing. So for existing bridges, if you want to know the precess, there are other solutions. So for new bridges only, the load cells can be fixed. So that is why the recommendation is for the future bridges only, but that should be done. Yes, sir.
What is about how we should solve this problem? We need external precessing for old bridge.
Which one, sir?
for old bridge, we have to do external pre-stressing, post-tensioning. So there is no any provision made because the bridge are very old. So how this problem can be solved?
Yeah, external processing we can do for existing bridges. We can do the external post-tensioning. Then first we have to do the preliminary investigation about the bridges. So if the girder is, we have to do the testing, condition assessment testing, that the NDT and other testing we have to do that. Then afterwards, if the eye girder is the steel, tensile steel is not yielded means it is not in the ultimate state. So we can do the retrofitting by external post-tensioning. For doing the external post-tensioning, we have to do the anchorage. We have to do the anchorage in the shear region. So, but that will be different from case to case. Every bridge will be a different case. So,
and in case of box girder?
Yeah, box girder also we can do that. Box girder also we can do that. And there have been cases that we have been done the retrofitting by external post-tensioning of box girder also done.
Thank you.
So the main thing is then there is a loss of precess. Because loss of precess only the bridges are distressed. That is the second part only. So if you install the vibrating wire load cell in the bridges, then earlier we can detect the distress. So before leading into the high level of severe distress, before that we can detect the distress early and we can plan for the retrofitting. Thank you, sir.
The fourth presentation is on carbon smart road development of technical textile from end of life plastic waste by Sri Mahesh Kasture.
Thank you, Chairman, sir. Thank you, Co-Chairman, sir. Good evening to all of you. I'm extremely delighted to let you know this is for the first time we are presenting this new concept on this open forum. And I also would like to say that I'm not a civil engineer. I'm an odd man out here. I'm a material scientist by profession. But when an idea conceived by a material scientist, and if collaboration done with a polymer scientist, chemical engineer, civil engineer, when they come together, then what miracle can happen? Probably this project will be one of the wonderful example of that. As you are aware that plastic in 90s or 2000 era, it is called as a wonder material. Everybody was so happy when this material was invented, this baby was born, and everybody is happy that we got something new. But just in 25 years, this baby started showing its color. And now it's a notorious material. So just a journey of 25 years, a nice baby become a notorious baby. But since we have created, we have to give the solution to this. One important thing is that segregation, cleaning, everything, people have done a lot of things to make it economically viable, but you know that still the situation remains same, so we have to accept this is our raw material. And in any of the process, unless and until the process is economically viable, the scalability is there, no industry is going to accept it. This is a fact because at the end of the day, what matters is the balance sheet. And if the last column of the balance sheet is positive, then only the process get into the market, otherwise it will remain into PowerPoint. So we have accepted that this particular material as a waste plastic, this is available, as a litter plastic everywhere. Can we use this as a raw material, convert it into a product, and that product can be used in road construction? This was the basic fundamental idea. With this idea, we have started. This novel product development has taken place initially with the module which we have already presented in a last IRC. And that product has more or less has taken a good shape, and we are moving forward with its modernization right now. This module has been constructed and those modules has already been applied in the surface of the road, and now we have come up with a new product that is called as the geocells. As you are aware that currently the geocells are being prepared from HDPE, and we have replaced that with a mixed type of base plastic. This is the plastic that is mix of everything, cannot segregate it. As a result of that, the initial research studies that we have carried out shows that we are getting a good structural stability. So the technical parameter, CRRI is our partner, my colleague Gagan is here. So all those studies, basic studies, we have already carried out. And we have found that whatever the technical parameters, those need to be matched in order to apply it. Those parameters we already achieved. As you know that we are trying to address this issue by means of reducing certain layer, because at the end of the day we have to achieve the economics while applying this product into our road construction. So some experimentation we have done, and we are trying to attempt to reduce the consumption of a certain layer by applying this geocell in road construction. So the economics of application and the cost economics of this geocell can be perfectly matched. So the first product when we have developed, we approach National Chemical Laboratory, Pune. We worked with the scientists of National Chemical Laboratory. We have established the properties because the raw material keep on changing. You don't have any control over raw material. But when you say it is a product, it should have certain physical properties, certain chemical properties. It should have certain strength in order to apply in road construction. So having that, this particular process that we have already patented, the patent is granted. So we have worked with NCL Pune, and we optimize the property such a way that when you apply, it should have a certain specific strength as well as a temperature stability. With this, we approach CRRI, and we have signed an agreement with CRRI that this product has already been optimized, and now we would like to further test it for its technical stability in a real case scenario. So we come up with two products that I have already mentioned. One is a waste plastic module that we have already applied in a surface. We already laid 14 sites across India, utilizing about 250 metric tons of plastic waste with the first process. And the second process, we have converted it into a geocell. So this is for the first time that we did. So we approach CRRI, and this laboratory studies has already been carried out by them. Once we optimize the parameter of geocell, we of course vary the thickness. We worked on the flexibility and all those things. The studies have been carried out. And once we optimize those parameters, then we approached Tata Roads. So there is a project that is already going on with Tata. So we have applied this particular product in one of the stage in the Tata projects. And we have carried out a couple of sample stretches there. And all those tests which is required to establish the feasibility of a geocell has been done with proper arrangement of truck, proper arrangement of all machinery sensors with the help of CRRI. And once we got appropriate, this is the geocell that you can see. Right now the process is manual, not a big deal. This process can be very well converted into an automation process. It's a matter of machinery that we can very well do. So if you see that we have got the desired result that the pressure measurement, all those studies have been carried out, and we found that we have about 15% of reduction. Once this test pilot scale, small pilot scale is successful, then we approach NHAI. And we have got a stretch on this Delhi-Mumbai highway, which is, you know, there is a connecting on Sarai Kale Khan, there is a highway going towards Mumbai. So that first stretch that we have got, and we have laid a stretch there. So all the sensors and all the whatever is required, that has already been placed at the bottom, so we will get the data when the traffic is moving. So I'll just run a small video so that you can see that this is the highway, Delhi-Mumbai highway, and this has been taken, the picture, it has been picturized with the drone. So this geocell has already been laid on almost 600 square meter area. No change in procedure, whatever the road making procedure, it remains same. The same GSS, the same JCB is coming, filling the material. The material is having enough strength. When it is filled, the JCB will walk over it. And there are no deterioration on the geocell side. So this has been completed, and this is already, we are already using it since last couple of months. This road has already been prepared. And this road has been inaugurated by the Director General of CSIR, Dr. Kalai Selbiji, in presence of dignitaries, senior experts from civil industry as well. As you know that currently the geocells are being prepared from HDP, so the energy required to prepare a pure HDP, this particular graph shows the energy required to prepare a pure HDP, so that has been saved. Since we are using a waste plastic, we are replacing this HDP. And if you compare the utilization of this energy, then what kind of equipment and how this energy we can utilize for other purposes, that also has been highlighted. We can power the street light, we can power the houses. So about 120 to 240 people per month against only 1 ton of HDP. So the energy required to produce 1 ton of HDP can be utilized to power the houses or power the street lights. So this is the kg equivalent of CO2. This you all are aware, and let me tell you that as per the CPCB report, the 1 metric ton of plastic corresponds to about 3 metric tons of CO2. And this particular process, in 1 kilometer, we are utilizing about 80 metric tons of plastic waste. You can just multiply what kind of CO2 that we are going to get. Not only that, it is also equivalent, the CO2 emissions, if you compare it in terms of trees, so it comes about to be about 120 trees. So certainly there are applications that we are exploring for slope. And you know it is having, there are a lot of demand in the market. The geocells are widely used even now in our petroleum industry when we are preparing gantry, when we are preparing new retail outlets, new petrol pumps. We ourselves consume a lot of this material. So we require this material. So certainly there is a good market for this particular material. So we have presented it to the Honorable Minister, and this is the new technology, and we would like to go ahead with this particular process. And I'm happy to let you know that he has encouraged and he directed that few more number of trials that needs to be prepared so the technology can be made robust and it can be made commercialized. As far as the implementation is concerned, as far as the cost economics is concerned, I won't comment much on that, but I can assure you it is economically viable, that we have already achieved. Because unless and until we do that, it will not go forward. Since the process right now is mechanical, only we need to convert it into automation, that we are right now already working on that. Hopefully in a couple of months or maybe in a year's time, we will make this process automatic, so the laying can be done. I take this opportunity to thank my management giving me permission to present this work with you. I also thank CSIR, CRRI. I express my sincere thanks to IRC for giving us an opportunity to present this work here. Thank you so much to you.
Thank you, Mr. Mahesh. Any questions from the audience? Yeah, please.
Geocell. It is just below soling.
Hello?
Gagan, can you take technical questions?
Yes. In pavement construction, that geogrid is to be given at which layer? Base course layer?
Gagan, you can join me here.
Can you come up, please? Okay. So, the geogrid is to be given in which layer of the pavement?
Sir, actually,
subgrade layer or base course level?
geogrid is usually put up at a lower layers in between the WMM or sub-base level. But the product which the sir has shown to you, it is a GeoCell. So it is a different product than the GeoGrid.
Okay.
Yeah.
Then second question is, what is the effect to cost? How much cost in percentage you can also tell?
Sir, as sir already has mentioned, technically, first we are basically coming with the this feasibility. So now this has been confirmed, and at the end of the day, after more trials, we are definitely land the cost so that it will match or it will not affect the overall costing per kilometer.
Okay. Thank you.
It is not only a plastic, I like to mention, because we have achieved 3 targets. You can use the waste material or that local C&D waste can go into this. We have we have given you a solution where you can use the plastic. And the last is, you can basically, it is a on ground, you can basically give us your, you add to the, directly the missions of the Government of India to Swachh Bharat and carbon sequestration, CO2
Okay,
sequestration.
no, benefits will be there. But what is the, whether you can roughly tell 1 per kilometer, suppose double lane road, what is the involvement of the additional cost?
Sir, cost will not increase.
It will not increase. Okay, thank you.
It has been mentioned here that it can be given in the subgrade layer. Subgrade layer, that GeoCell can be given.
Sorry?
In the subgrade layer, can it be given in the subgrade layer?
We can give the subgrade layer also.
Okay, if it is given, whether it reduces the thickness of the subgrade?
So at present we are basically taking the dead data because we have to compare the present conventional thickness which give for the different kind of a traffic movement. So we are taking the data and we will come up after the 6 months how much we can, with this GeoCell we can reduce the pavement thickness.
Okay, does it work like reinforced earth structure?
Yes sir, because first aim is to basically develop the product which can replace the conventional or GeoCells, so that here the target is to have a beam effect.
Thank you. I think there are 1 or 2 points which you have to consider. The first point is that you have to define what is that end of life. How to define end of life. What is meant by end of life. You need to respond, but consider these points. Second is that the effectiveness of GeoCell depends upon many factors like the thickness of GeoCell, the stiffness of GeoCell, the material that is used in the fill. I suggest you to refer to the paper, research report published in the Illinois Center for Transportation, where they have given a detailed report as how to find the effectiveness of GeoCells in load distribution. Third is that for any pavement design, we wanted the resilient modulus of the GeoCell. So you have to carry out experimental studies and come out with that. Fourthly, IRC SP59 talks about GeoCells. When you talk about a new end-of-life waste plastic, how are the properties different from the conventional geosynthetic specified in IRC SP59? This again, you have to do a fatigue test in the laboratory wherever required, and then come out with the results. So then only the application can be appreciated. Thank you.
Thank you so much for your input, sir. Thank you.
The fifth presentation is on biobitumen, a sustainability initiative for road construction by Dr. Idaya Raj Devota, General Manager, IOC.
Next. Thank you, Chairman. Thank you, IRC, for this opportunity, and very good evening to everyone. So I am Dr. Devota from Indian R&D. I am a General Manager, and I will be presenting on our recent initiative, biobitumen, sustainability initiative for road construction by Indian Oil. So what is biobitumen? I think everybody knows what is biobitumen. Normal conventional bitumen are petroleum based. It is the vacuum residue. It is produced from the vacuum residue. The last portion of the vacuum column is bitumen. And biobitumen is non-petroleum based. It is from the renewable source. So either a lot of biomaterials are being used, and it is partly replaced, normal conventional bitumen is partly replaced with biomaterial to, as far to the extent possible, to meet the specification. So why biobitumen matters? There are several advantages. Environmental and sustainability advantage, because we are heavily dependent on crude oil, and we are importing a lot of crude oil. 75% of our crude oil is imported. So our reliance to crude oil will decrease if you develop something which is sustainable and within the country. And it's also a waste management technique, and because a lot of agricultural waste gets burnt and causes pollution, which is very common in the NCR region. Apart from that, we have a lot of economic advantage. If you develop something within the country, you depend less on the imported bitumen and importing crude, and it saves foreign exchange. And it also promotes bioeconomy. It helps farmers, and it helps in increasing opportunities and employment in rural areas. Apart from these, of course, very important, performance-wise, biobitumen have been very promising with improved rutting resistance, improved fatigue cracking, and moisture resistance. So what are the sources of biobitumen? There are several sources. Due to lack of time, I will just say there are two types of biomaterial that are being used for biobitumen, solid or liquid. Solid, mostly they are lignin-based, and liquid, either it is vegetable oil or bio oil produced from pyrolysis of different biomass or animal waste, etc. IOC's biobitumen is based on lignin. Having said about lignin, we should know what is lignin. Lignin is a biobinder. It is naturally available in the crop mass, and it is something that is known for more than 2 centuries. Botanists have identified this material for more than 2 centuries before, and it is actually found in the cell wall of the plant cells. And this lignin gives the actually rigidity and the strength to the crop. Otherwise, the crop will not, it cannot go vertically. And it's hydrophobic in nature because of its rich aromatic subunits. And if you see the structure of lignin, it's too complex. It's a 3D structure, and it is even complex than the conventional bitumen also. So having said about lignin, where do we get lignin? How IOC sources lignin? If I have to talk about that, I need to briefly tell about our 2G ethanol plant. So as you know, ethanol has become the center point of the automotive fuel today, and about 20%, up to 20% blending of ethanol is happening in gasoline. So IRC has gone for ethanol production through our biorefinery. And this process is called 2G process, that is producing ethanol from waste crop mass. 1G process produces ethanol from edible mass like sugarcane and corn. Here we use waste crop mass, and this process is called second generation ethanol plant. And crop mass is nothing but lignocellulose raw material. It contains both lignin as well as cellulose. And during a series of process, when the crop mass is processed, the cellulose portion gets converted into ethanol, while the lignin portion remains as a residue as a bioresidue from the plant. And this residue is about almost 60% of the crop mass. So every ton of crop mass, we produce about 200 kg of ethanol and about 600 kg of residue byproduct rich in lignin. So having a residue rich in lignin, we thought we should explore a way to valorize this byproduct and produce a biobitumen. So this is the methodology we have followed. The biomass is converted into ethanol in our plant, and the residue remains. And this residue we have utilized in our bitumen formulation through a wet mixing process. Wet mixing process means we are putting directly into the bitumen. There are two types of process, wet mixing and dry mixing. Wet mixing is putting it directly into the bitumen, and dry mixing is putting into the, along with aggregate in the hot mix plant. And we tried some laboratory experiments using this residue from the lignin-rich residue from our plant, and the basic properties of we have tested, and we found that it is highly encouraging. And we have also tested the performance of the bituminous mixtures like rutting, moisture stability, moisture resistance, and all of them were encouraging. And based on these encouraging results, we decided to go for a full-scale commercial production, trial production in our Panipat plant. So this is our commercial production unit. First batch of commercial trial was taken in March this year, and biobitumen was produced. We produced about 20 tons of first batch, and this 20 tons was used for a trial road construction in the road just outside our R&D center in Faridabad. And this is the methodology of your production, and we have done all the characterization of the trial product and as per specification, and it was found acceptable. So the material produced was used for a trial road in April 2025. The location is our own R&D public road outside our R&D center, about length of about 250 meters with 13 meters wide. And we used control section also, along with biobitumen. For reference, we have done a control section also. And the current condition of the road after 6 to 7 months is excellent. And we have signed a MOC with Central Road Research Institute, New Delhi, for a comprehensive performance assessment. And we are also planning some more trials in our Panipat Refinery Township. We have about 10 kilometers road inside, so some stretch will be laid with this biobitumen. So about the assessment plan, as you know, CRRA has huge expertise on trial road and performance assessment. So we have tied up with them for an assessment of 2 years. And this is the tentative assessment plan, visual rating, formation of cracks, potholes, deformation, rutting, etc. There will be also equipment-based assessment to measure the deflection, Beckelman being deflectometer, falling weight deflectometer, and extraction of cores will be taken and the cores will be analyzed. And of course, classified trophic volume survey also will be done. And based on this data, the road will be rated as per IRC guidelines, IRC 82, on a 3-scale parameter, good, fair, and poor. So to summarize my presentation, so IOC is producing ethanol from in our biorefinery using crop mass, and from this plant we are also getting a huge amount of bioresidue rich in lignin. We have explored this byproduct to make biobitumen, and the lab results were very encouraging. Trial production and construction of trial road has been already completed. Performance evaluation for a period of 2 years will be initiated, and more trials are planned in Panipat area. This sustainability and green initiative will reduce import dependency and foster bioeconomy. Thank you.
So any questions from the audience? I think if there are no questions, I'll ask a question. You can answer. Yeah. You have mentioned, first of all, first question is that why did you add biobinder to a crumb rubber modified bitumen? Why did you not use it, mix it with VG30 or VG40?
Yeah, we have done that also, but the amount of biomaterial going into CRMB will be higher.
Now, why I am asking this question is that I am not able to appreciate what is the function of the crumb rubber and what is the function of the biobinder. So I should be able to find out the contribution of the biobinder in the performance improvement.
Yeah, biobinder, as far as rubber is concerned, it is increasing the elastic recovery.
That's what elastic recovery is not an indicator for a long-term performance.
Yes.
It's perhaps this is for future studies. Secondly, when you make a presentation, when you say it improves crack resistance, rutting resistance, moisture resistance, you should be able to present the results.
Okay.
How does it improve? What is the chemical reaction that is taking place that introduces this improvement in the performance? This is what I have. I think you need more experimental results, cost economics,
Yes.
constructability issues also may be presented when you make the next presentation.
Okay.
Yeah. Thank you.
Yes, yes. Just I would like to add something. What will be the cost impact on the construction of using the normal bitumen and this biobitumen? Have you ever studied the cost comparison?
Cost will be reduced because we are replacing 10% by biomaterial, and it's a residue from our biorefinery. That product is actually getting burnt in the boiler. The existing application is it is getting burnt in the boiler as a low value material. So we are replacing bitumen, so the cost will be less.
No. Is it exactly you have replaced the bitumen, but what is the impact? What is the cost? Have you compared it with the normal bitumen and this biobitumen?
Cost of bitumen?
No, the construction cost.
No,
of a road.
the construction cost, we didn't find any impact because everything was normal, nothing.
It is to be studied. Actually, it will play a very vital role to have a economic road construction in our country.
Yeah. That's a valid point. It is not only the initial cost that matters, the maintenance, performance protection
Yes.
also matters.
Okay, that time will tell and the assessment will tell.
That's what in that presentation, you please include at least laboratory performance studies on rutting, cracking, moisture damage.
That
will
I've
give an
already
indication.
done.
Yeah, thank you. And the last presentation is on experimental study, effect of headlight glare, visibility of traffic signboards, condition of helmet visor on situation awareness of two-wheeler driver, vis-a-vis road safety by Dr. Vinod Karar and Mrs. Kamini Gupta.
Okay. Respected Professor V. Raghavan sir, chairperson of the session, Ayaz Ahmad ji, co-chair of the session, and dear delegates, good evening all. First of all, I would like to thanks to IRC organizers to allow to present this experimental study, as this has been conducted first time in India. And this study is the joint effort of 3 prestigious institutes. First, CRRI, MNIT Jaipur, and CSIO. And this experimental study is the effect of headlight glare, which studies the visibility of traffic signboards and condition of helmet visor on situation awareness of two-wheelers drivers. The outline of the study is like this. The background, introduction to glare. Actually, the glare is a very common topic, but the quantitative study on glare, how it affects to the drivers and to the traffic signage, that is the most important thing which we have covered by setting up the experimental study using the lab study as well as the field conditions. As we all know, the road safety contest in India, this the two-wheeler stats is like this. It contributes to the 46% of total number of accidents. So here in this study, we have considered the two-wheeler riders who are the higher risk due to the direct exposure on road. And the nighttime risk is almost 3 times higher as compared to the daytime. What is the headlight glare? How it affects? In our study, like if we say the ongoing headlight, it distracts the driver and reduce the reaction time which creates the inadequate braking and the vehicle severe. The vehicle moves in the different direction and ultimately it leads to the accident risk. How the headlight affects, it depends on the time of the day, the light time infrastructure, the weather condition, as well as the seasonal changes and the urban and rural settings. As we all know, the infrastructure at the traffic intersection ranges from 10 to 1 lakh lux. These are the different examples of Indian road conditions where we all suffers how the headlight it glares and how it affects on road and to the drivers. These are the factors related to the headlight glare, the road lighting, driver eye position with respect to the road surface is the most critical condition. The helmet visor condition, age of the rider, driver behavior, headlight source technologies. And this is the vast literature's review we have done on headlight glare and its visibility. I'm not going into its detail. And this is the helmet visor technology and safety research. And the research gap, we found why we have done these studies, because there is a very limited quantitative studies on visor-induced light scattering effects under the controlled glare condition with the precise lux measurements. Here in CRRI, we are having the dark lab, and we are having the all type of signage facility there, and we have created our study on this by setting the different conditions. And to the same person, to the same driver, we have done the study on the infield also. These are the global standards and regulation and safety initiatives on helmet visor technology and safety research. What was our research objective in this study? To evaluate the impact of headlight glare from different vehicle types, motorcycles, cars, buses, on traffic sign visibility. And ultimately, we identified the critical glare threshold affecting the situation awareness of two-wheeler riders. These are the helmet visor critical safety factors, like the visual complication. This is our three-phase experimental methodology where we have set up the laboratory as we are having the lab in the CRRI, and we have done that in the controlled condition and then in the field conditions. This was our experimental setup. And now I hand over to Dr. Vinod Karan to discuss about the results and its conclusions.
Respected chair, respected co-chair, dignitaries on the dais and off the dais and delegates. Now I'll present the results. As we can see on the left side, we have a graphical representation when the street lights, road lights are on the right side when the road lights are off. On the upper side, without helmet. When I say with helmet, it means visor is on, and without helmet means no helmet or visor is on the upper side. So we can see without helmet, what happens is that when street lights are on, regulator signs blur at 60% of the glare intensity. Here the maximum glare intensity we have considered is 251 lux, which we were able to generate using our sources. And they vanish totally at 100% of the light, that is 250 lux. Difficulty started at 50%, and without street lights, that which simulates the rural conditions, the situation worsens dramatically. And signs disappear at just 30% of the maximum intensity. This establishes our baseline that rural darkness makes riders 40% more vulnerable to the glare effects. Now, with street lights on and visor, and this is the graph, in the previous graph was with motorcycle rider seeing the light and the glare source was the motorcycle light. Here the source is the car light. So when the glare source is car light, the car headlights at just 10% of intensity make regulatory sign blurry because of their height vis-a-vis position of the driver. At 20%, they vanish completely without street light and with visor. Typically, rural night riding, no signs are visible from 10 to 100% of intensity. That is 251 lux. Now third is with the burst light. Burst light even creates more problem. This is why when we did the road study, 100% of drivers told that whenever they find the glare, they would lift the visor. So what is the finding? That helmet visor cause visible degradation at 60 to 75% lower lux values than riding without visor. And the visor meant to protect you actually creates a light scattering effect that amplifies glare more than double. Now lux is the illuminance which falls on a surface, which means so we have measured the light which is falling on the eyes, that we have measured the illuminance in the form of lux. So now if you see this graph, we will find that visible, as we told that without street lights the sign detection take 83 seconds if we are continuously looking at light. If you suppose you look at this light for say 5 seconds, then you will not be able to identify the face on the front. So this is what the glare does, and with street lights on, detection drops to just 28 seconds. So which means that infrastructure lighting is very important to control the glare. But remember, in our visor test, even with street lights on, the riders couldn't see the sign that is informatory and the regulatory signs at all under high glare. And this is why we feel that infrastructure lighting is absolutely critical. So we also correlated every condition with precise lux measurement. For example, we can see here at 23.5 lux, visibility score is 0.417, and at 106 lux, the sign blurs significantly, and at the maximum, that is 251 lux. Typically, which is a multi-vehicle scenario, this number now gives us quantitative threshold for safety standard. That is, at the lux values of glare more than 251 lux, the visibility would become 0. Now we will summarize the lab results with and without helmet. Without helmet, street line on, regulatory signs blur at 106 lux, and they become totally invisible at 250 lux. Without street lights, visibility loss occurs at 30-40% earlier. Now with helmet visor on, degradation starts at just 38 lux. That is 60 to 75% lower than the without visor. And for bus headlight, at eye level create maximum disability glare because the lights are more intense. And in rural condition with visor, complete sign detection failure occurs across all the levels. That is when there is no infrastructure lighting. The wheeling glare effect from visor scattering reduces contrast sensitivity by 40 to 60%. In fact, wheeling glare is something like when you have more scratches on the helmet, the light would scatter, and the effect will be different. The driver would get confused, and glare effect would be amplified. Regarding real-world field measurements, in actual road conditions, things are far worse. Previously, I told about the lab measurements, but in real conditions, multi-vehicle glare zones, bus plus car plus motorcycle combination create lux in excess of around 500 lux. That is nearly double our maximum of 251 lux. These high intensity events occur every 6 to 8 seconds. Each event causes 10 to 20 seconds of sign invisibility. So what we find that riders experience sign invisibility for almost 1/3 of their total travel time. The human visual systems require 5 to 7 seconds depending on their age and physiological adaptability, but with continuous 10 to 400 lux fluctuation, a 48:1 ratio, your eyes will never reach equilibrium. You just see this light for 5 seconds. You will not be able to see the faces properly. So this is the effect of glare. And it will be more if we are wearing the spectacles. So, so then we did a survey questionnaire also, and 80 to 100% experience visor intensified glare, often to always. 100% reported delayed or missed sign identification. 60% found rural condition more challenging due to minimal ambient lighting. All of them confirmed scratchy or dusty visors worsen glare significantly. Behaviorally, 100% prefer riding without visor at night. And all riders lift visors during high glare exposure. So we have identified few glare thresholds based on our limited study, that visibility degradation accelerates beyond around 100 lux with ambient lighting. Regulatory sign blur at 106 lux, and they become completely invisible at around 250 lux. With use of visor, the degradation starts at around 40 lux, and discomfort glare threshold consistently exceeds 100 lux in real condition. Multi-vehicle scenario peak at 450 to 500 lux. So it is very safe to operate below 50 lux for clear visor visibility. But for rural lights, again 48:1 luminance ratio, crisis is there. So as you know that we always talk of photopic condition, that means a well-lit condition where our cone cells are more active, and mesopic condition where light is less, both cones and rod cells of eyes are more active. So in well-lit photopic condition above 9 candelas per meter square, which is the luminance, allows optimal visual acuity. Under low light mesopic condition, less than 1 candelas per meter square, it critically affects the night driving. This range requires modified visual processing, and especially older drivers are vulnerable with this prolonged glare recovery. However, we find that older drivers would not look into the glare, they would look sideways. So they find ways to overcome those things. And when we also did some, we are winding up. So we also did study at the intersection. We found that the measurement values were almost 3 to 4 times more than the mid-block values, values measured in the mid-block road sections. And two-wheelers at 1.4 meter height are in the peak vulnerability zone relative to car and bus headlights. Your truck headlight could be, driver position could be 2.6 meter, but at 1.4 meter, every vehicle will contribute to the glare to the driver. We also studied international best practices. European Union they have made mandatory the adaptive driving beams since 2021, and they claim to have reduced accidents by 25%. Australia has utilized comprehensive intersection lighting and claim to have achieved a reduction of crashes by 35%. And Japan, smart headlamp technology with augmented reality display. So they have also improved awareness by 30%. And US is trying to adopt to adaptive headlight process. So we have proposed a 4-layer safety approach. That means technology should be there in the form of product. We should have a physical interventions in form of infrastructure lighting, public awareness, and the policy interventions. So immediate actions could be mandatory multi-vehicle glare testing protocols, visor anti-glare coating with less than 5% light scatter. Rather, I would say that there should be 4 coatings on the helmet. One is the hydrophobic coating, anti-dust coating, anti-scratch coating, and anti-reflective coating. If we see the helmets which we use, they generally come with a bare polycarbonate substrates. Their transmission is less than 90%. If we use the good anti-reflective coating, the transmission could be increased as high as 98%.
Conclude.
Yes. So these are the few technologies which we have developed as CRRI. We have developed devices to measure glare by using developing a wearable light and glare measurement device and a portable device which could be used for measuring glare on the substrate. We have also developed technology for glare mitigation. We have done some results. It is under IP process, so I will not discuss much on this. So that is all from my side. Thank you.
I think because of the time limitation, whoever wants a clarification can contact Vinod and then interact after the session. I request my co-chair to conclude the session.
Thank you. All the presentations which were given by our 6 presenters are very important and very having insight on each specific topic, especially biobitumen, which is a sustainable initiative for road construction. It will be a game changer if it is used in bulk. So it will improve our road industry, having a less impact on carbon emission. Basically, road safety has also been presented by the way of effect of headlight glare. It is also a very common subject and very important, especially for two-wheeler riders, which are very affected in day-to-day. Actually, each presenter has tried to say a very specific points, but I would like to say carbon smart road, which is very important and very a sensitive issue, which has been taken by using live plastic waste. It is also very important, and more study is to be done, is needed to be done to have the menace of plastic. Thank you all.
Thank you very much. Thank you all for your patient hearing. I hand it over to you. Yeah, thank you.
Thank you so much, sir, for your concluding remarks. And now may I request Professor A. Veeraraghavan, Chair of the session, to kindly present a memento to our presenters. Sir, kindly come forward. Can we please increase the volume of my mic? And starting with Engineer P. Alango, Deputy Director, HRS Tamil Nadu, and along with him, J. Kavita Madam. Thank you so much, sir, for a very knowledgeable presentation. Ladies and gentlemen, we are having J. Kavita Madam. Give a round of applause to her as well. Dr. Praveen P.S., Scientist, and Sri Ashish K. Azad, Scientist, National Transportation Planning and Research Center, Kerala. Please, sir. Sri Ashik K. Azad, Scientist, National Transportation Planning and Research Center, Kerala. I can't hear any noise of your clappings. We can do that, right? Next, Dr. R. Manisekar, Senior Principal Scientist, Advanced Concrete Testing and Evaluation Laboratory, Tamil Nadu. Thank you so much, sir, for your insightful presentation. Next, we are having Sri Mahesh W. Kasturi, BPCL, Uttar Pradesh. Next presenter, Dr. Iruday Raj Devota, General Manager, Bitumen and Separation Process, Indian Oil Corporation, Haryana. Thank you so much, sir. And lastly, we are having Dr. Vinod Karar, Chief Scientist, and along with him, Mrs. Kamini Gupta, Senior Technical Officer, CRRI, New Delhi. Thank you so much, ma'am and sir, for your very, very knowledgeable presentation. Thank you. Ma'am, please. And now it's time to felicitate our chairperson and co-chairperson of the session. And to do the honor, may I please request on stage Sri Priyabrat Samantrai, Chief Engineer Buildings, Works Department, Odisha. So, ladies and gentlemen, we had Professor A. Veeraraghavan, the chairman of the session. So requesting Shri Priyabrat Samantrai sir to kindly felicitate him with a flower bouquet and a memento from our side. We appreciate your presence and we appreciate the sharing of your knowledge with all of us, sir. Thank you. And we were having Shri Ayaz Ahmed as our co-chair of the session. And may I kindly request all the presenters to kindly come forward along with our chairperson and co-chairperson for a group photograph, please. Thank you so much, everybody. Thank you. This was the last session here in Hall 2. Thank you so much, everybody, for your presence and your valuable time. We'll continue the technical session for tomorrow, sharp at 9:30 a.m. in the morning. Please be here. We're going to have some interesting topics for tomorrow. And for now, let's move ahead and enjoy the cultural program as well. Thank you so much, everybody, for your time. Good night. Jai Jagannath.
Hello, hello, check, check. Hello, hello, check. Hello, hello.